Welcome to the Found My Fitness podcast. I'm your host, Rhonda Patrick. Today, we're taking a deep dive into alcohol. Alcohol is one of the most heavily used and abused drugs. It is also a very controversial topic, in part because alcohol plays such a large role in societies and cultures around the world, and it's generally accepted as a normal part of life. There is also a lot of confusion about alcohol. There's no doubt that alcohol can have a personal and public health impact. On the other hand, research in the last few decades suggests that not only may a moderate intake of alcohol may not be harmful, but it may also be protective against certain diseases, which again is a heavily debated idea. This has led to a divide among scientists, public health professionals, and government organizations over what guidelines should be around alcohol consumption. My goal at the end of this podcast is to have given you enough information that you can make an evidence-based and informed decision about your own drinking habits. I'll do this first by defining what a standard drink is and the different drinking categories. Then I'll discuss biochemistry of alcohol and how it's metabolized in the body, with a particular emphasis on the effects on the gut and liver. Then we'll take a deep look into the literature regarding alcohol and several chronic diseases, including Alzheimer's and dementia, cancer, cardiovascular disease, and diabetes, and delve into the mechanisms by which alcohol may increase or decrease the risk of these diseases. We'll also go into some of the very popular topics like how alcohol affects your sleep, whether or not you can prevent a hangover, how alcohol affects sexual health and fertility, the interaction between alcohol and exercise, and how alcohol consumption relates to health span and longevity. In the last part of this episode, I'll talk about options for quote-unquote damage control, practical suggestions for mitigating alcohol's adverse effects on health. Granted, there is not a lot of evidence out there for harm reduction strategies, but we'll explore some speculative methods for reducing harms from alcohol and how to use them, and when applicable, any research. Even if you're not someone who consumes alcohol, I know you'll learn a lot from this episode. On that note, let's talk about alcohol. First, let's define what it means to have a drink. In the United States, one standard drink is 14 grams of alcohol, which is one 12-ounce can of beer, 8 to 10 ounces of malt liquor or flavored malt beverages like hard seltzer, 5 ounces of wine, and 1 shot of 80-proof distilled spirits such as gin, rum, tequila, vodka, or whiskey. Importantly, the amount of liquid in your glass might not match how much alcohol is in your drink. That's because most regular beers have an alcohol content of around 5%, while wine is about 12% alcohol by volume and distilled spirits are about 40% alcohol by volume. So even though these drinks come in different sizes, they all contain roughly 14 grams of pure alcohol. So this is important. Although these amounts are used for making the guidelines, they might not reflect customary serving sizes at most bars or restaurants, meaning that if you decide to have a drink, be aware of the size that you're getting. Some pours are very heavy. Since a lot of the research we'll be covering today will compare different alcohol intake levels, it's also important that we define these categories for clarity. We'll use the definitions proposed by the Centers for Disease Control and Prevention, or CDC. But it's important to note that these definitions, like those for what constitutes a standard drink, may vary widely across countries. For example, a standard drink in the US is equal to 14 grams of alcohol, while a standard drink in China, France, Ireland, and Spain is equal to 10 grams of alcohol. Current infrequent drinkers are people who consumed 1 to 11 standard drinks in the past year. Current light drinkers are people who consumed at least 12 drinks in the past year, but on average consumed 3 standard drinks or fewer per week. Current moderate drinkers are women who consume more than 3 drinks, but less than 7 drinks per week, and men who consume more than 3 drinks, but less than 14 drinks per week on average. And current heavy drinkers are women who consume more than 7 drinks per week, and men who consume more than 14 drinks per week. None of these categories include a definition of alcohol use disorder, formerly known as alcoholism, which has its own unique definition. Alcohol use disorders include alcohol abuse and alcohol dependence, which are two different disorders that have been integrated into one single disorder in newer definitions. So alcohol use disorder, AUD, is defined as a medical condition where someone has an impaired ability to stop or control their alcohol use despite experiencing several social, work-related, or health-related consequences. Alcohol use disorder can be classified as mild, moderate, or severe depending on the number of symptoms someone experiences. Because the levels of alcohol intake in epidemiological studies often differ from the CDC definitions, the World Health Organization uses a measure called heavy episodic drinking, which is defined as consuming 60 grams or more of alcohol on at least one occasion in the last 30 days. That would be equal to just over 4 standard drinks in the United States and up to 6 in other countries like China, France, Ireland, and Spain. Binge drinking is defined as having 4 or more drinks for women and 5 or more drinks for men on at least one occasion in the last 30 days, or having enough alcohol to bring your blood alcohol concentration to 0.08% or more. In this case, a drinking occasion is considered to be 2 hours or less. Interestingly, binge drinking may have unique effects on the body when compared to low or moderate alcohol intake. We'll talk more about that later when we discuss how alcohol affects different aspects of our biology and physiology. We'll talk about the health risks or potential protective effects associated with the drinking categories shortly, but I'll note that the National Institute on Alcohol Abuse and Alcoholism categorizes quote-unquote low-risk drinking as having no more than 3 drinks on any single day and no more than 7 drinks in a week for women, and no more than 4 drinks on any single day and no more than 14 drinks per week for men. This is important because it recognizes that total weekly alcohol consumption is important, but so is the pattern with which you drink. Now, let's talk about alcohol metabolism. What happens to alcohol when we drink it? Our blood alcohol concentration is determined by 4 factors. 1, how much alcohol is consumed, whether or not there is food in our stomach, factors that affect our rate of gastric emptying, and the rate at which our body oxidizes alcohol. Alcohol is one of the few drugs, that's right, it's considered a drug, that gets absorbed into the blood through our gastric mucosa. Alcohol enters the duodenum, the first part of our small intestine, from the stomach. However, some of the alcohol we consumed is oxidized in the stomach by an enzyme known as alcohol dehydrogenase, or ADH. This is known as first-pass metabolism. While the stomach does play a minor role in the metabolism of ethanol, the liver is the major site of ethanol metabolism. Our liver can't store alcohol. Over 90% of alcohol oxidized, with the other 10% being excreted in our breath, sweat, and urine. So things are about to get a little nerdy, so bear with me. In step 1 of alcohol metabolism in the liver, the enzyme alcohol dehydrogenase, or ADH, catalyzes the oxidation of ethanol. This process also requires a vitamin-related cofactor known as nicotinamide adenine dinucleotide, or NAD, which accepts hydrogen atoms and electrons in a process known as reduction to become NADH, and a free hydrogen. So 2 hydrogen atoms are removed from alcohol in this step, and the toxic ethanol metabolite known as acetaldehyde is formed. In step 2, acetaldehyde is oxidized into acetate by an enzyme known as aldehyde dehydrogenase, or ALDH. Another molecule of NAD is reduced to NADH in this step. In step 3, acetate leaves the liver and enters circulation, where it's activated to acetyl coenzyme A, known as acetyl-CoA. So acetyl-CoA is the very same metabolite that is produced from the breakdown of carbohydrates, fat, and protein. The carbon atoms from alcohol wind up as the exact same products that our body produces from the metabolism of other macronutrients: carbon dioxide, fatty acids, ketone bodies, and cholesterol. There is also a minor pathway of alcohol metabolism that might only occur at high blood alcohol concentrations. This pathway involves the metabolism of alcohol by the enzyme cytochrome P450-2E1, or CYP2E1. At a higher blood level of alcohol, the rate of alcohol oxidation increases, and much of this is said to be due to the activity of CYP2E1 rather than alcohol dehydrogenase. So CYP-E21 levels increase with chronic alcohol consumption and may play an important role in alcohol metabolism in people with alcohol use disorder. There's also been a lot of study and much debate about what part of alcohol is actually responsible for its damaging and reinforcing effects. Is it ethanol? Is it an ethanol metabolite like acetaldehyde? Or is it something else at play? So the most current evidence suggests that alcohol and acetaldehyde are responsible for some of the neurotoxic and behavioral effects of alcohol consumption, and that acetaldehyde modulates rather than mediates ethanol's effects. Of course, some of the effects of alcohol are also due to reactive oxygen species that are produced when ethanol is metabolized into acetaldehyde and then acetate. And it's difficult to place the blame on any one compound or process when in reality they kind of all interact in a complex way. So alcohol is not always metabolized at the same rate, and therefore it will affect our blood alcohol concentrations in different ways depending on genetic factors and other conditions of our body. So let's talk about some of the factors that influence how quickly or how slowly we metabolize alcohol. For one, there are genetic differences in metabolism that can be explained by variations in alcohol metabolizing enzymes. So for example, variants of the genes for aldehyde dehydrogenase 2 or alcohol dehydrogenase 1B cause the accumulation of excess acetaldehyde after alcohol consumption. So this can lead to elevated levels of oxidative stress in the body and are one of the reasons why people with certain variants in these genes don't consume alcohol, because they experience facial flushing, nausea, and rapid heartbeat when they drink. These mutations are common in people of East Asian ancestry, but rare in people of European ancestry. A study of Chinese adults found that the prevalence of low alcohol tolerability alleles was between 21 and 69%, higher than the 0.01 to 4% prevalence in European populations. Because these alleles are randomly allocated at birth and are independent of other lifestyle factors, they're often used as a proxy for habitual alcohol intake in epidemiological and Mendelian randomization, or MR studies, to assess how alcohol consumption affects disease risk. There is also a variation in the alcohol dehydrogenase enzyme, ADH1B, that results in a faster rate of alcohol breakdown into acetaldehyde. Specifically, the ADH1B3 allele of the ADH1B gene is associated with a faster rate of alcohol elimination and an intense initial response to alcohol ingestion. But it is also associated with protection against alcohol-related birth defects and alcohol use disorder. This allele is found in about 1/4 of people of African descent. While I'm on the topic of genetics, I do want to bring up a question that several FMF members had about whether alcoholism or alcohol use disorders can be inherited. It seems that about half of someone's susceptibility to developing alcohol use disorder is determined by genetics, and the other half is environmental. No, there isn't an alcoholism gene, but some gene variants have been associated with a greater or lower risk of developing this condition. To use just one example, people with one variant of the mu-opioid receptor, which is involved in the brain's reward circuitry, experience a large dopamine increase when they consume alcohol, while people with another more common variant do not. So these people are at a higher risk of developing alcohol use disorder because of the euphoric and the other positive subjective effects they get after drinking alcohol. People with a family history of alcohol use disorder also have a larger dopamine response to the expectation of consuming alcohol, even when they have a similar dopamine response to actually consuming alcohol as people without a family history. This is just some evidence that alcohol use disorders may, quote unquote, run in the family, even though at the moment we don't know the entire story about which gene or genes are involved. Okay, let's get back to talking about alcohol metabolism. Food can also impact alcohol's metabolism. When we have food in our stomach, this slows the rate of gastric emptying and reduces the absorption of alcohol. That's why it's common advice to never drink on an empty stomach. You're probably wondering if there's a specific type of food or meal that is best for slowing the metabolism of alcohol, but it doesn't seem so. High fat, high carbohydrate, and high protein meals all appear to be equally effective at slowing gastric emptying. Being in the fed state also increases alcohol metabolism because our levels of alcohol dehydrogenase, the enzyme that metabolizes ethanol to acetaldehyde, are higher, and our ability to transport the reducing equivalents into the mitochondria is elevated. So food may also increase liver blood flow, and certain sugars like fructose may also increase alcohol metabolism by aiding in the conversion of NADH to NAD and enhancing oxygen uptake by our mitochondria. So in one study performed in healthy men, consuming fructose along with alcohol reduced the time that the participants were intoxicated by 30% and increased the elimination of alcohol from the body by 45%. So eating some fruit with a meal before you drink may help lessen its negative effects, and this could also involve mixing alcohol with fruit juice, which also contains fructose. I do want to note that although this improved ability to metabolize alcohol may come at a cost, consuming alcohol and fructose together actually worsened blood glucose and triglycerides when compared to alcohol or fructose alone. In short, having a meal before drinking alcohol seems to be an incredibly strong factor at influencing alcohol metabolism. You'll have lower blood alcohol response to the same amount of alcohol if you drink with a meal or eat a meal before drinking. Additionally, adding some fruit or fructose into the mixture may also affect alcohol metabolism. And finally, let's talk about aging. Many people swear that they can't drink as much as they age or that they experience a worse hangover with the same amount of alcohol. But the age-related differences in alcohol metabolism or tolerance haven't been extensively studied. Based on what's published, there do not seem to be differences in the rates of alcohol metabolism or elimination between younger and older adults. But older adults may actually experience less hangover symptoms due to a lower consumption of alcohol, a longer drinking experience building up to greater tolerance to alcohol, a lower pain sensitivity, or even the fact that older adults may tend to drink more expensive types of alcohol with a lower congener content. The evidence here is very murky, and for most people, it might not really matter what the science says, only about your own subjective experiences regarding alcohol tolerance with age. But before diving into the research on how alcohol affects various aspects of our health, it's important that we understand the biochemistry of alcohol and how this plays into changes in nutrient absorption, indirectly through displacing beneficial nutrients, and also directly by altering absorption and metabolism. The empty calories provided by alcohol could suppress our appetite and reduce our intake of real food with beneficial nutrients, and it may also impair the absorption of the nutrients that food does provide for us, including macronutrients and micronutrients. Alcohol causes changes in our intestinal lining that impair nutrient absorption and cause more nutrients to be lost. We'll go into a bit more detail on these mechanisms now. Alcohol, or more accurately, ethanol, is considered to be a nutrient along with carbohydrates, protein, and fat. This means that alcohol has a caloric value, which is about 7 calories per gram, higher than protein and carbohydrates at 4 calories per gram, but lower than fat at 9 calories per gram. But unlike carbohydrates and fat, which our body can store and utilize for energy during times of need, for example, fasting, alcohol is not stored in the body. Rather, alcohol remains in our bloodstream until we metabolize it. All of this is to say that alcohol is quote unquote empty calories because it doesn't contain beneficial nutrients that contribute to our health. In fact, alcohol interferes with our body's ability to break down and absorb critical micronutrients. This is likely because of a few reasons. For one, alcohol may displace food in our stomach and suppress appetite. Alcohol also interferes with the absorption, storage, mobilization, activation, and metabolism of nutrients. Mounting evidence has reported that heavy drinking may influence the absorption of glucose, glutamine, vitamin B2, vitamin C, vitamin B1, vitamin B9, iron, zinc, and selenium. How exactly does alcohol interfere with nutrient absorption and metabolism? Ethanol causes structural changes in the intestinal mucosa, affects our microbiome composition, disrupts the gastric mucosal barrier, modifies cellular junction protein and membrane dynamics, and increases intestinal permeability, also known as quote-unquote leaky gut. This inhibits the enzymatic digestion of nutrients and disrupts the absorption of nutrients in the small intestine in a crucial area known as the brush border membrane. Unfortunately, there aren't many dose-response studies that have investigated the effects of low, moderate, mild, heavy drinking on nutrient absorption, but we can gain insight from studies performed in adults with alcohol use disorder. These individuals have increased nutrient requirements due to a greater metabolic demand and the need for tissue repair and a result of their heavy drinking. They also absorb fewer nutrients from the food they're eating. A variety of nutrient deficiencies have been reported in adults with alcohol use disorder, including 20 to 50% greater prevalence of calcium deficiency, a 20 to 50% greater prevalence of magnesium deficiency, a 6 to 80% greater prevalence of deficiencies in many of the B vitamins, and a 14 to 58% greater prevalence of deficiencies in vitamin C, D, E, and K. Alcohol could also lead to deficiencies in two micronutrients that are indispensable for our body, zinc and magnesium. Both are involved in literally hundreds of different enzymatic reactions and serve crucial biological functions. Alcohol causes us to absorb less zinc in the intestine and excrete more zinc in urine. This is a double whammy for this micronutrient because we both absorb less and excrete more. Heavier alcohol use is definitely associated with poor zinc status. Between 30 and 50% of people with alcohol use disorder have low zinc status. However, moderate alcohol use may have a milder effect on zinc losses. In either case, regular consumption of alcohol probably increases the need for more zinc in the diet or supplemental zinc, at least slightly in people who are low or moderate consumers. Alcohol consumption also increases magnesium excretion in a dose-dependent manner, with chronic heavy alcohol intake increasing excretion up to 2 to 3-fold. These are just some of the examples of alcohol's effect on micronutrient levels in the body. And even though drinking small to moderate amounts of alcohol isn't likely going to, frankly, make you deficient in any one micronutrient, I don't think it would be a bad idea to supplement with extra micronutrients on days when you do choose to consume alcohol as nutritional insurance. Since we're on the topic of nutrient absorption, which happens in the gut, I think it's a good time to talk about how alcohol can affect gut health. There's a fascinating bidirectional relationship between alcohol and the gut microbiome. Not only does drinking alcohol cause changes to the gut, but there's also some evidence that microorganisms in the gut could make us more susceptible to alcohol use disorders. Before touching upon the gut microbiome, I'll discuss how alcohol can directly affect the structure of the lining of our intestine. Normally, our physical intestinal barrier functions to keep bacteria inside our gut and away from our circulation and the other organs. But when this barrier is compromised, bacterial translocation can occur, during which bacteria pass from the gastrointestinal tract into our body. Alcohol and its metabolites, as well as reactive oxygen species produced during alcohol metabolism, cause damage to the cells in the intestinal barrier and weaken cell membranes, which can lead to quote-unquote leaky gut. Leaky gut can happen through transepithelial and paracellular mechanisms. The transepithelial mechanism occurs when materials pass directly through the epithelial cell membrane into our intestine. Alcohol can disrupt the gut barrier integrity through paracellular mechanisms too. So materials pass through the junctions or small gaps between the epithelial cells in the intestine. This occurs because alcohol metabolites disrupt the tight junction proteins and proteins responsible for creating a stable cytoskeleton. Cell cytoskeletons are crucial because they are the borders that give cells their structure, and evidence from studies in humans has shown that administering alcohol at a dose of 20 grams, just over one standard drink, is sufficient to disrupt two key tight junction proteins known as zonia occludens 1 and occludin. So we've established that alcohol can cause increased intestinal permeability or leaky gut through several mechanisms, but you're probably wondering why this matters. Well, alcohol-induced leaky gut means that not only will alcohol cause intestinal inflammation, but it will also cause inflammatory cytokines as well as gut bacteria and other toxins to leave the gut and migrate to other organs throughout the body. One of the most well-known of these so-called endotoxins is known as lipopolysaccharide, or LPS. LPS provides a structural barrier to bacterial cells and is normally only present in the luminal or inner side of our intestinal cells where it doesn't cause damage. But if LPS is able to cross the intestinal barrier through some sort of mechanisms we just discussed, it can enter the bloodstream where it's highly toxic and has been linked to type 2 diabetes, heart disease, and liver disease. LPS in the bloodstream induces an inflammatory response, increasing the levels of cytokines including TNF-alpha, interleukin-6, and the chemokine MCP-1. Furthermore, some of the pathogenic bacteria released from the gut can cross the blood-brain barrier and enter into the brain. What we are left here with is a vicious cycle whereby intestinal permeability can lead to an elevated inflammatory response, which can further lead to intestinal permeability dysfunction and an even greater inflammatory response. It's no wonder why chronic heavy alcohol drinking is associated with a multitude of diseases. Of course, you don't have to be a chronic heavy drinker to experience these effects. A single binge drinking occasion, consuming 4 or more drinks in a single occasion, elevates LPS levels in the bloodstream for up to 3 hours. However, chronic heavy drinking, defined as more than 4 drinks per day for men or more than 3 drinks per day for women, is associated with higher levels of circulating LPS when compared to non-heavy drinking, which correlates with their having higher levels of gut permeability. This is important. Higher levels of alcohol consumption are associated with higher LPS levels. More drinking means more gut permeability. But the good news is that the effects of alcohol appear to be reversible because levels start to decline with abstinence from alcohol. In fact, just 19 days without alcohol was enough to reduce gut permeability levels of adults with alcohol dependence to those observed in adults who reported consuming about 1 drink per day. It's clear that alcohol can have direct, negative, and potentially long-lasting effects on intestinal barrier integrity, potentially provoking a widespread immune response throughout the body. I'd hesitate to say that these effects are highly detrimental if you're only consuming 1 to 2 drinks at once and don't consume a chronic high amount of alcohol. However, it does seem that even just 1 drink can promote some disruptions in intestinal barrier function. A final topic related to gut health that I want to discuss is the fascinating and relatively new science of the gut-brain axis, which refers to the communication network between our central nervous system and our gut microbiome. The gut microbiome refers to the collective genome of over 100 trillion microorganisms that live in our gut. And it's now clear that the gut microbiome should be considered an organ in and of itself. Our gut bacteria can communicate with our brain and influence our brain function and behavior, such as anxiety, mood, cognition, and pain. This gut-brain axis or gut-brain interaction is mediated by the immune system, the enteric nervous system, the neuroendocrine system, and the circulatory system, as well as the vagus nerve, all of which receive information from alterations in gut microbiota, which either promote or prevent the development of certain behaviors or diseases. For this reason, a healthy gut microbiome could be important for preventing or treating alcohol use disorders because of the microbiome's influence on the brain. Something you may not know is that the neurotransmitters and neurohormones aren't just produced in the brain, but also in the gut. For example, the gut bacteria known as lactobacillus produces the neurotransmitter GABA. The gut bacteria known as Enterococcus can produce serotonin, and the gut bacteria Bacillus can produce dopamine. If we don't have adequate levels of these bacteria or imbalances in their levels exist, the neurotransmitter levels may be disrupted. It does seem that alcohol can kill some of the good bacteria in the gut and promote the proliferation of some of the bad bacteria and allow them to escape the gut due to quote unquote leaky gut. Certain gut-derived compounds may also influence alcohol intake and may be another way in which the gut could give rise to alcohol addiction. Injecting LPS into mice increases their alcohol consumption and prevents alcohol-conditioned taste aversion. You heard that right. The bacterial endotoxin that is increased in response to heavy alcohol consumption actually promotes more alcohol consumption through immune signaling mechanism. In one particular study, the increase in alcohol consumption lasted almost 3 months after the injection of LPS. These results and others have led some researchers to conclude that the composition and activity of the microbiome may cause some people to be more susceptible to alcohol use and other substance use disorders, with some estimates as 30 to 40% of all alcohol use disorder cases having a gut-related component. If true, this means that targeting the gut microbiome could provide an alternative and maybe a more effective treatment for alcohol use disorder, because currently the treatments that target brain chemistry aren't very effective and have a very high relapse rate. While strategies for gut health in people with alcohol use disorder or with gut-related conditions that might predispose to it haven't been widely studied, there are a few promising options. Probiotics and prebiotics may improve the composition of the gut microbiome, improve the gut barrier integrity, and reduce inflammation in the gut, leading to improved symptoms. There are also several other healthy lifestyle interventions with some evidence in support of their ability to improve intestinal permeability, such as increasing your consumption of dietary fibers, consuming higher levels of omega-3 fatty acids and polyphenols, and engaging in regular exercise, which has been shown to support intestinal health. However, none of these strategies has been used in people with alcohol use disorder per se. What I think we can take from this discussion is that the relationship between alcohol and gut health is not unidirectional. Consuming a high quantity of alcohol can lead to intestinal inflammation and gut permeability, and it can also disrupt the gut microbiome and contribute to bacterial growth in the small intestine. However, the health of our gut microbiome can also influence our psychological health and potentially impact our urge to consume alcohol. Let's quickly recap this section on alcohol and gut health. In contrast to some of the other topics we've been discussing, there's not a lot known about the dose of alcohol that will lead to adverse changes in gut microbiome composition or compromise intestinal barrier integrity. But it's clear that heavy chronic drinking is bad. Individuals with alcohol use disorder, alcohol dependence, or who consume more than 4 drinks per day for men and more than 3 drinks per day for women usually have poor markers of gut health than even social drinkers do. Now it's time to explore the influence of alcohol on disease risk, but I first want to discuss one crucial methodological concern that arises in most observational studies on alcohol use, the sick quitter and healthy user effect. These two biases have often been used to explain why. Quite often, moderate drinkers appear to be healthier than non-drinkers or abstainers in observational studies. These studies are often criticized for being influenced by confounding variables. These are characteristics of the participants that aren't accounted for but influence the results significantly. In studies of alcohol use, participants may be misclassified into a drinking category that doesn't accurately reflect their past or current habits. The sick quitter effect is one such misclassification. Let's say that someone used to be a heavy drinker but decided to quit after they developed a few health issues as a result of their alcohol consumption. When asked about their drinking status, they may characterize themselves as a non-drinker when really they have been a former drinker, but a current abstainer. So if studies don't correctly account for this, then a group of self-reported non-drinkers may include former drinkers who quit due to illness or other reasons. This may result in groups of non-drinkers having higher risks of certain health conditions compared to moderate drinkers because of the former heavy drinkers in this group are in worse health condition. The healthy user effect, sometimes called the healthy user bias, is explained by the fact that healthier people are more likely to self-select as drinking moderately and responsibly. This provides a non-casual explanation for why in some studies, abstainers show a higher risk of chronic diseases than moderate drinkers. It's not the alcohol per se, but other health characteristics that moderate drinkers might have. For example, light and moderate drinkers have been shown to have better dental hygiene, exercise routines, weight, diet quality, and income compared to abstainers. Several other behavioral and social factors related to cardiovascular disease are much more prevalent in non-drinkers than in moderate drinkers. So when studies adequately control for these confounding factors, most and sometimes all of the protective effects of alcohol on disease risk are eliminated. In other words, the moderate drinkers are healthier despite their drinking habits, not because of them. Even when these biases are accounted for, there's another issue when using observational studies to infer causality. People are lousy at reporting their alcohol intake and may tend to report a lower alcohol intake due to social desirability. All of this is to say that the research on alcohol and health span and longevity isn't set in stone, and much of what we have to rely on at the moment is, unfortunately, epidemiological data and all of its inherent limitations. Okay, now it's time to really talk about how alcohol impacts our health. Because it may be the organ most impacted by the effects of alcohol, let's start with the discussion on how alcohol affects the brain. In particular, I'm going to focus on alcohol's relationship with cognitive decline, dementia, and Alzheimer's disease. First, let's take a look at how the brain responds to alcohol consumption and why, at least initially, most people feel good after a few drinks. Since alcohol is water and fat soluble, it is able to cross the blood-brain barrier and enter the brain, where it has effects on nearly all brain regions. When social drinkers, people who drink occasionally and don't have alcohol use disorder, first consume alcohol, there's a significant activity in parts of their brain called the ventral striatum and nucleus accumbens. These brain areas are key components of the reward system, which means that they help process feelings of pleasure and reward. The consumption of alcohol triggers these areas to release dopamine, a neurotransmitter and neuromodulator that most of you know is often referred to as the feel-good chemical because when it is released, it is what provides feelings of pleasure and satisfaction. The increase in dopamine not only generates feelings of pleasure, but also reinforces the behavior, making the act of drinking alcohol enjoyable and potentially encouraging repeated behavior. This reinforcement is why activities that stimulate dopamine release, like drinking alcohol, can become habitual. This reaction is part of why drinking can feel rewarding and enjoyable, especially in social settings. This increase in dopamine contributes to the reinforcing effects of alcohol and leads people to want to drink more. In people with alcohol use disorder, this dopamine increase is blunted. For the same amount of alcohol, people with alcohol use disorder experience less of an increase in dopamine, which is probably because these individuals have been shown to have a lower dopamine receptor density and lower dopamine transporter density compared to people without alcohol use disorder. A lower dopamine response to alcohol means that these people need a larger dose of alcohol to feel good and explains why they drink more and drink more often after developing a tolerance to alcohol. Alcohol consumption initially causes an increase in serotonin due to its interaction with the brainstem's serotonergic neurons, particularly in areas called the median raphe and dorsal raphe. These neurons are crucial because they project to parts of the brain that regulate our impulses, our motivation and reward systems, and our stress and anxiety responses. When you first drink alcohol, these serotonergic neurons are stimulated to release more serotonin, which contributes to the feel-good sensations often experienced in early drinking. This is why those first few drinks can feel particularly rewarding and relaxing. However, the metabolic byproducts of alcohol, like acetaldehyde, disrupt this circuitry. As drinking continues, this effect isn't sustainable. Serotonin levels and the activity of serotonergic neurons begin to fall. This decrease is why the initial positive effects of alcohol wear off after a few drinks. To chase that initial high, people might consume more alcohol trying to recapture those good feelings. But this strategy is ultimately flawed. The brain's adaptive response means that continued drinking leads to reduced overall brain activity, particularly in areas that govern alertness and arousal. Thus, further drinking results in diminishing returns, leaving one less alert and more subdued. The initial effects of alcohol on dopamine and serotonin partially explain why a few initial drinks can make us feel energized, happy, calm. Alcohol also activates an area of the brain known as the ventral striatum, which is activated in response to rewarding behaviors or stimuli, which also probably explains some of the euphoria that people experience when they're intoxicated. Some people drink alcohol to reduce anxiety. This effect is primarily due to alcohol's interaction with the neurotransmitter called GABA. GABA is known for its inhibitory functions in the brain. It calms neural activity, leading to a decreased anxiety and more relaxed state. Alcohol acts as a GABA receptor agonist, which means it enhances the effect of GABA, increasing this calming effect. Simultaneously, alcohol reduces the levels of glutamate, an excitatory neurotransmitter. This reduction in excitatory signaling further contributes to a general slowing down of brain activity, enhancing the calming effect. Additionally, alcohol impacts how we perceive and respond to threats. For instance, functional MRI studies have shown that under the influence of alcohol, there is a reduced activation in the brain's visual and limbic systems, which are crucial for detecting and responding to threats. This means that not only does alcohol chemically reduce anxiety by modulating neurotransmitter levels, but it also diminishes our physiological responses to fear-inducing stimuli. Even though alcohol may reduce anxiety in the short term, drinking to reduce your anxiety is not the best solution. while highly anxious people may experience a greater anxiolytic effect in response to alcohol, especially in social situations, this type of reinforcement could lead to a dependence on alcohol and increase one's risk for developing an alcohol use disorder. Although some people use alcohol temporarily to reduce anxiety, the long-term consequences often negate any short-term benefits. Alcohol temporarily reduces anxiety by enhancing the function of GABA, a neurotransmitter that inhibits neural activity and promotes calmness, as we mentioned. However, as the effects of alcohol wear off, there's a rebound effect that not only returns anxiety levels to baseline, but can actually significantly increase them. This heightened anxiety following alcohol consumption, commonly experienced during a hangover, is sometimes referred to as hangxiety. This term captures the increased anxiety that follows the initial calming effects of alcohol. Research has shown that individuals with higher levels of social anxiety experience more severe hangxiety the day after drinking compared to those with lower levels of social anxiety. This suggests that the temporary relief provided by alcohol might exacerbate anxiety symptoms in the long run, particularly in those initially consuming alcohol to manage their social anxiety. After the initial anxiety-reducing effects of alcohol wear off, several factors contribute to a rise in anxiety levels. Firstly, alcohol significantly disrupts sleep patterns. While it may help in falling asleep faster, it generally reduces the quality of sleep, particularly REM sleep, which is crucial for emotional regulation. Poor sleep alone can heighten anxiety in the following day. We are going to discuss the effects of alcohol on sleep in a little bit. Let's revisit how the body's neurochemical environment changes in response to alcohol. Initially, alcohol increases GABA activity. This reduces anxiety. But with regular consumption, the body compensates by down-regulating GABA receptors and up-regulating glutamate receptors. This shift not only reduces alcohol's calming effects over time, but it leads to increased excitability in the brain during withdrawal or hangovers, thus elevating anxiety. Additionally, the physical symptoms associated with the hangover, such as nausea and fatigue, result from the body metabolizing alcohol into acetaldehyde, a toxic byproduct. This process can further exacerbate feelings of anxiety and irritability. The worst approach to this heightened anxiety is to drink more alcohol in an attempt to alleviate the discomfort. This can lead to a harmful cycle where the individual relies increasingly on alcohol to manage their anxiety, potentially leading again to dependence and worsening of the overall anxiety condition. Although this was only a cursory overview of alcohol's effect on different areas of the brain and certain neurotransmitters, I do hope it was enough to answer some of your questions about how and why alcohol makes us feel good and then maybe not so good. But now I want to pivot to discuss some of the research on alcohol and brain health. This is a fascinating area that there are some incredibly insightful studies that can inform us about the long-term effects of alcohol on the brain. There's one heavily referenced and incredibly informative study in this area that I want to lead with because it's been used as one of the main pieces of evidence as to why any amount of alcohol seems to be detrimental for the brain. The title of this study is Associations Between Alcohol Consumption and Gray and White Matter Volumes in the UK Biobank. The UK Biobank is a research database with health information from more than 500,000 European participants, and this study included data from about 36,678 individuals. This study highlights the significant impact even moderate alcohol consumption can have on brain structure. Consuming just 1 to 2 units of alcohol daily, equivalent to roughly half to 1 standard drink in the US, is linked to reduced overall brain volume. This reduction includes both gray matter, which consists of neuronal cell bodies and is crucial for processing information, and white matter, which involves the connections between different brain regions. The way alcohol is measured in the study is critical to understanding its effects. In the UK, where the study was conducted, what's considered 2 units of alcohol is equivalent to 1 standard drink in the US, such as a can of beer or a glass of wine. This means the detrimental effects on brain volume can occur at lower levels of alcohol intake than might be assumed by those using UK standards. Furthermore, the study supports existing evidence that alcohol contributes to cerebral volume loss, particularly affecting brain white matter. This loss impacts areas crucial for memory processing and visual spatial functions. In more severe cases, like those seen in individuals with alcohol use disorder, heavy consumption leads to the loss of neurons in several critical brain regions, including the hypothalamus, cerebellum, hippocampus, and amygdala, areas involved in regulating emotions, memory, and spatial navigation. Alcohol has profound negative effects on the brain, primarily through its impact on nutritional absorption, direct toxicity, and inflammatory processes. Let's break down these mechanisms. First, alcohol consumption can lead to a deficiency in thiamine, or vitamin B1, which is essential for nerve function and brain health. This typically occurs in two ways. First, alcohol can impair the absorption of thiamine from the digestive tract. Second, it can inhibit the body's ability to utilize thiamine. This is because thiamine needs to be converted into its active form by an enzyme that alcohol inhibits. Additionally, this conversion process requires magnesium, another nutrient often depleted by alcohol consumption. The resultant thiamine deficiency can lead to decreased cellular defense against oxidative stress, contributing to brain damage. Some of this damage may be related to iron toxicity. Thiamine, also again known as vitamin B1, helps maintain the integrity of the blood-brain barrier. A thiamine deficiency could impair the blood-brain barrier function, allowing more iron to deposit into the brain. This is known as the brain iron overload and thiamine hypothesis, and though it is supported by some animal and neuroimaging studies, it is yet to be fully validated in humans. I will mention one study that observed an association between alcohol consumption and brain iron levels. Consuming more than 7 units of alcohol per week was associated with higher iron levels and worse cognitive function among a cohort of more than 20,000 participants from the United Kingdom. I definitely think there is some support for the idea that iron in some way plays a role in alcohol-related cognitive decline. Acetaldehyde toxicity is another mechanism I want to talk about. When you drink alcohol, your body metabolizes it into acetaldehyde, a substance that is toxic to brain cells. This compound can damage DNA and proteins within brain cells, leading to cellular dysfunction and cell death. Neuroinflammation is another mechanism. So alcohol affects the gut-brain axis, as we discussed earlier. This is a direct communication pathway linking your GI tract to your brain. Heavy drinking increases gut permeability. This is referred to as leaky gut. This can lead to the release of pro-inflammatory cytokines into the bloodstream. Once these cytokines are in the bloodstream, they cross the blood-brain barrier. They cause inflammation within the brain. Additionally, alcohol can increase glutamate, the excitatory neurotransmitter. It can activate the stress response system, further promoting brain inflammation. This inflammation is mediated by the activation of microglia and astrocytes. They're the brain's resident immune cells, which then release even more inflammatory mediators and cytokines, resulting in this vicious cycle. So the ongoing activation of these pathways by chronic alcohol consumption leads to sustained inflammation, which is detrimental for brain health, and it manifests as a significant neuronal loss, reductions in brain volume observed during even moderate drinking. All of this information doesn't paint the rosiest picture of alcohol and brain health. And based on this evidence, it would probably seem best to keep alcohol intake to below 1 drink per day. However, when we take a look at the epidemiological and clinical evidence on the relationship of alcohol to neurodegenerative diseases, the story does change a bit. Research shows that alcohol's impact on brain health and cognitive function is quite nuanced. A number of studies have found that light to moderate alcohol consumption in middle to late adulthood is associated with a reduced risk of cognitive impairment and dementia, while heavy alcohol use and alcohol use disorder increase the risk for these diseases. There are lots of methodological differences among the studies in this area, so we'll do our best to try to make sense out of this evidence to try to provide some practical recommendations. Some studies suggest that the risk reduction associated with light to moderate drinking may be as high as 26 to 28% for dementia and Alzheimer's disease, but others suggest that the protective effects may be more modest. In one analysis of 10 prospective studies, a lower risk for dementia was found to be between 0 and 7.5 drinks per week, or just under 1 standard drink per day. But the lowest risk, a 10% reduction, occurred at 4 drinks per week. However, it's crucial to understand the dose-dependent response relationship alcohol has with cognitive health. So once consumption exceeds about 23 drinks per week, which equates to more than 2.5 drinks per day, the risk for dementia significantly increases. This suggests that while moderate drinking might offer some protective effects, excessive alcohol use certainly outweighs these benefits and poses substantial risks. Unfortunately, some of the studies did not account for the sick quitter bias that we talked about earlier. Remember that the sick quitter effect occurs when studies include both former drinkers and lifetime abstainers in the non-drinking group, which can artificially increase the risk for adverse health outcomes in the abstainers compared to light to moderate drinkers. This is especially important for brain health because the lasting effects of former heavy alcohol use on the brain may not be completely reversible after someone stops drinking, although there is some evidence of a partial recovery of brain white matter in former heavy alcohol users after a period of abstinence. However, even studies that do account for the sick quitter effect have found a beneficial association between light to moderate drinking and the risk for dementia in middle-aged and older populations, whereas heavy drinking is often associated with a greater risk. So a study of adults between 35 and 55 years old found that abstinence from alcohol in midlife was associated with a 40% greater risk of dementia when compared to light to moderate alcohol consumption. This is of 1 to 14 units per week, an association that was still significant after taking former drinkers and abstainers into account. Drinking more than 14 units of alcohol per week was not associated with a greater risk of dementia, however, among adults consuming more than 14 units per week. Each 7-unit per week increase in alcohol consumption was associated with a 17% increase in dementia risk. A protective effect of light to moderate drinking seemed to be mediated by cardiometabolic disease, so rates of which were higher in abstainers. We'll talk about the role of cardiometabolic health when we discuss the mechanisms that could explain the protective effects of alcohol on brain-related diseases. Another comprehensive analysis brings together data from over 15 international studies focusing exclusively on adults over the age of 60. This age specifically is crucial because it addresses a population at an increased risk for cognitive decline and dementia. The study's design cleverly accounts for what's known as the sick quitter effect. Again, this bias where individuals who have stopped drinking due to health issues might skew results if considered alongside lifelong non-drinkers. So in this study, drinking categories were defined as follows. Occasional drinkers consume about 1 drink per week. Light to moderate drinkers consume up to 2 drinks per day. Moderate to heavy drinkers have about 3 drinks per day, and heavy drinkers consume more than 3 drinks per day. The findings are quite revealing. Compared to those who abstain from drinking, occasional and light to moderate drinkers had a 22% lower risk of developing dementia. Those who drank moderately to heavily saw an even greater reduction with a 30% decreased risk. However, drinking more than 3 drinks daily did not show a statistically significant increase in dementia risk compared to abstainers. Additionally, when isolating the data to only include current drinkers, the differences in dementia risk between light to moderate and moderate to heavy drinkers were no longer statistically significant. So this suggests that while moderate alcohol consumption might be associated with a reduced risk of dementia, moderate to heavy or excessive drinking does not have greater protective benefits and may plateau or even potentially lead to negative outcomes. So what can we take away from this study is that moderate alcohol consumption, particularly less than 2 drinks per day, might have a protective effect against dementia in older adults. However, escalating to higher levels of alcohol intake does not seem to provide additional benefits and could be risky. I would say one noteworthy limitation of this study is the age of participants, which was 72 years. Because none of the participants had been diagnosed with dementia at the time of the study, it's quite possible that these people had already a low general risk for dementia in the first place. So the results might not apply to the general population or people with a genetic predisposition to dementia. So speaking of genetic predisposition, now might be a good time to bring up apolipoprotein E3 and apolipoprotein E4. This is a topic that many people, including Found My Fitness members who submitted questions for this podcast, may have concerns about. So there's a significant interaction between genetics and lifestyle factors that affects our brain health as we age. One specific area of interest is the ApoE4 allele. It's a genetic variation that is known to increase the risk of Alzheimer's disease and dementia. So apolipoprotein E, or ApoE, is a gene that provides the instruction for our body to make apolipoprotein E, which combines lipids, cholesterol, and triglycerides to form lipoproteins. There are three common variations or alleles of the ApoE gene: ApoE2, ApoE3, and ApoE4. The ApoE4 allele is associated with an increased risk of dementia and Alzheimer's disease and an earlier age of onset of these diseases in some populations. Around 15 to 25% of people have one copy of the ApoE4 allele, and 2 to 5% carry two copies. Having one copy of this ApoE4 allele elevates Alzheimer's risk around twofold compared to having no copies. And having two copies of the ApoE4 allele can increase the risk of Alzheimer's disease up to tenfold. If you want to determine whether or not you're a carrier of the ApoE4 allele, you can do this by ordering a genetic test kit from one of the many available services such as 23andMe, Ancestry DNA. And you can also run a free genetic report to determine your ApoE status by uploading your genetic data to the Found My Fitness website. Very few studies have investigated whether ApoE4 modifies the association between alcohol and dementia or Alzheimer's disease risk. Some evidence suggests that the risk of dementia increases along with increasing alcohol consumption in people with one or more copies of the ApoE4 allele, but not in people without the ApoE4 allele. So carriers of the ApoE4 allele who consumed alcohol less than once a month still had 2.3 times greater risk of dementia than carriers who never drank, and carriers who drank several times per month had 3.6 times greater risk of Alzheimer's disease. So to put it another way, increasing alcohol consumption in midlife increases dementia risk only in adults carrying one or more copies of the ApoE4 allele, at least when alcohol consumption stays below the threshold discussed earlier. Another study of older adults aged 59 to 71 years old found something similar for cognitive decline. Like previous studies, adults who reported consuming 2 or more alcoholic drinks per day had no copies of the ApoE4 allele, had a 30 to 74% lower risk of cognitive decline compared to non-drinkers. On the other hand, for adults with one or more copies of the ApoE4 allele, any alcohol was associated with a greater risk of cognitive decline, with 90% greater risk for 2 or less drinks per day, a 170% increased risk for 2 to 5 drinks per day, and a 730% increased risk for 5 or more drinks per day. Not all studies support a lower threshold for the negative effects of alcohol on dementia risk, such as one meta-analysis published in 2017, which actually found a protective effect of alcohol consumption up to 14 drinks per week among ApoE4 carriers, while protection was only observed up to 7 drinks per week among non-carriers. If we consider all these results, I think it's pretty clear that if you even have a single copy of the ApoE4 allele, you should limit your drinking to occasional, but 0 drinks appears to be the smartest choice to maximally reduce your risk of developing Alzheimer's disease or dementia. In any case, ApoE4 carriers don't appear to experience the protective effect of light to moderate alcohol consumption that non-carriers have, whereas most other epidemiological studies show that light to moderate drinking is associated with a lower dementia risk in people without the ApoE4 allele. Understanding how moderate alcohol consumption might positively or negatively impact dementia risk involves delving into the metabolic functions within the body. Let's break down some of the key processes involved. First, one of the hallmark problems in Alzheimer's disease and other forms of dementia is impaired glucose metabolism in the brain. The brain's ability to utilize glucose effectively is crucial for maintaining cognitive functions. Alcohol, interestingly, might help improve the brain's glucose tolerance. This is potentially due to alcohol's ability to increase the presence of insulin-sensitive glucose transporters, which helps cells absorb glucose more effectively, thus supporting better brain function. Another critical aspect is how alcohol affects cardiovascular health, which is directly linked to brain health. Moderate alcohol consumption has been shown to increase levels of HDL cholesterol. HDL plays a protective role in the cardiovascular system by helping remove other forms of cholesterol from your blood and preventing them from forming plaque in the arteries. Blood coagulation and platelet activity may also be involved. So Alzheimer's disease and dementia are also associated with abnormal platelet activity and other thrombotic factors that can affect blood flow. Alcohol can reduce platelet aggregation essentially. It can make platelets less sticky and less likely to form clots. This reduction in coagulation and improvement in blood flow can be beneficial for brain health by ensuring that the brain receives adequate blood supply, which is essential for its function and maintenance. There's one more mechanism I want to discuss, and that is alcohol's effect on the glymphatic system. The glymphatic system is our brain's highly organized system for cerebrospinal and interstitial fluid exchange, which is most active during sleep. It serves a few purposes. For one, it clears away waste products and metabolites from the intercellular space of the brain via lymphatic drainage vessels in the head and neck. These waste products, mostly proteins, protein aggregates, and metabolites, are then taken through circulation to the liver where they're degraded. Two proteins of major importance here are beta amyloid and tau, both of which are neurotoxic and have been implicated in the development of Alzheimer's disease. Proper function of the glymphatic system ensures that these neurotoxic proteins don't accumulate. In mice, acute and chronic exposure for 30 days to a low dose of alcohol of 0.5 grams per kilogram body weight, corresponding to about 2 standard drinks per day for a human, actually improved glymphatic activity, whereas intermediate and high doses, corresponding to about 8 and 21 drinks per day for a human, impaired glymphatic activity. These results line up with all of the evidence that we've just discussed on the seeming benefits of light to moderate alcohol consumption on dementia and Alzheimer's disease and the detriments of heavier doses. If any benefit indeed is due to alcohol, it might be via enhanced lymphatic drainage. But this probably requires that you avoid the negative impacts of alcohol on sleep because the glymphatic system is most active during this time. Sleep is when most of the brain's waste removal occurs. We'll talk more about how alcohol affects sleep very shortly. While the authors of this animal study caution that the results should not be used to make recommendations for alcohol consumption guidelines in humans, they do note that this may present a novel cellular and physiological mechanism contributing to the delay in onset of dementia in people with light alcohol intake, namely through glymphatic clearance. So at the very least, it is an interesting mechanism that should be explored further. Another interesting yet still debated idea in the realm of nutrition and brain health is the potential neuroprotective effects of compounds found in the non-alcoholic parts of alcoholic beverages like resveratrol found in red wine. Resveratrol is a polyphenol known for its antioxidant and anti-inflammatory properties. It has been studied for its ability to protect neurons by neutralizing free radicals, reducing inflammation, and enhancing neuronal energy metabolism. Some research has also suggested that resveratrol can improve cerebral blood flow and even aid in the clearance of beta amyloid proteins, which are implicated in Alzheimer's disease. However, there's an important distinction to be made here between the effects of resveratrol itself and the effects of drinking red wine. While resveratrol has been shown to have potential in laboratory studies, the actual amount of resveratrol in red wine is quite small, ranging from about 0.03 milligrams to 1 milligram per glass. To achieve the levels used in pharmacological studies, which are often between 50 to 500 milligrams, one would need to consume an impractical amount of red wine, literally thousands of glasses. Therefore, it's unlikely that the moderate consumption of red wine as part of a daily diet provides enough resveratrol to have a significant pharmacological effect on cognitive functions or neurodegenerative processes. So, while resveratrol is certainly a beneficial compound found in red wine, its concentrations in typical servings are too low to account for the observed health benefits associated with moderate wine consumption. This suggests that the other factors, perhaps even the alcohol itself, or a combination of other compounds and lifestyle factors associated with moderate wine drinkers, might be contributing to the protective effects noted in epidemiological studies on cognitive health and other diseases. So let's wrap up our discussion on the brain and hit a few takeaways from the research I've discussed. Alcohol's relationship with the brain is a tale of complexity and contradiction. On the one hand, studies show that light to moderate alcohol consumption might reduce the risk of dementia in individuals without an ApoE4 allele, which is a known genetic risk factor for Alzheimer's disease. This protective effect could be due to alcohol's influence on cardiovascular health, possibly improving blood flow to the brain and reducing inflammation, which are crucial factors in maintaining cognitive function. There is also some possibility that the lymphatic system activation could also play a protective role, but there's not enough evidence to support this last one yet. On the other hand, the same light to moderate drinking is associated with decreased brain volume. To understand this, it's important to recognize that the brain's structure and function are not always directionally correlated in a straightforward way. For instance, while reduced brain volume is generally viewed as negative, it does not necessarily translate to diminished cognitive function in this context. The key might lie in the body's resilience and compensatory mechanisms. The brain is highly adaptive and capable of compensating for certain types of structural changes. In the context of alcohol consumption, while there may be a general reduction in brain volume, the remaining neural networks might adapt in ways that maintain or even enhance cognitive functioning. This could involve the strengthening of synaptic connections or improvements in neurochemical signaling, allowing the brain to operate efficiently despite structural reductions. However, this compensatory capacity is not uniformly distributed across all genetic profiles. Individuals with the ApoE4 allele, which is the genetic variant linked to a higher risk for Alzheimer's disease, do not seem to exhibit the same level of neuroadaptability. For example, the ApoE4 allele has been associated with reduced neurite outgrowth, which is crucial for forming new neural connections. This genetic difference means that ApoE4 carriers may have less capacity to compensate for brain volume loss or other neural damages that occur with alcohol consumption. So it is my opinion that to be on the safe side, limiting alcohol consumption to 1 to 2 drinks per week on social occasions, perhaps weekends, is probably not going to give you dementia per se. Finally, if you're a carrier of 1 or 2 of the ApoE4 alleles, 0 drinks per day is associated with the lowest risk for neurocognitive diseases. You might want to limit your alcohol consumption to only social occasions, if ever. Because the brain and sleep are so intricately linked, I think it makes sense to talk about how alcohol affects sleep next. A lot of you had questions about how alcohol affects sleep and if there are any strategies to help lessen these effects, and that's definitely an area we will explore. If you have ever consumed alcohol close to bedtime, you're probably well aware of how alcohol impacts both the quality and quantity of your sleep. Most of the research on alcohol indicates that it primarily affects 2 areas of sleep: your sleep onset, or the time it takes you to fall asleep, and sleep quality, which also includes the architecture of your different sleep stages. Before we get into how alcohol affects sleep, it might be good to provide a quick refresher on the sleep stages. There are 4 sleep stages, including 1 rapid eye movement or REM sleep stage, and 3 that form non-rapid eye movement or non-REM sleep stages. Stage 1 is called N1. This is the initial stage of sleep, and it's the transition phase from wakefulness into sleep. It is a very light sleep where one can be easily awakened. During N1, the brain produces high amplitude theta waves, which are slower than the alpha waves that are dominating during wakefulness. So this stage typically lasts just a few minutes. The next stage is stage 2, also called N2. Following N1, you enter N2, which still counts as light sleep, but is deeper than N1. During N2, the brain begins to show sleep spindles and K complexes, which are patterns of brain activity that help protect the brain from waking up due to external stimuli. This stage compromises the majority of total sleep time for most adults. The next stage is stage 3, or N3 sleep, also referred to as slow wave deep sleep, due to the delta waves that characterize this stage. N3 is the deepest form of sleep. During this stage, the body repairs and regrows tissues. It builds bone and muscle. It strengthens the immune system. Deep sleep is crucial for physical recovery and health. It is also one of the hardest stages from which to be awakened, and disorientation or grogginess may occur if sleep is disrupted during this phase. We spend more time in deep sleep during the first half of the night, when these stages may last 20 to 40 minutes, and less time as the night progresses, which is why it is important to have a similar bedtime each night. Finally, there's REM sleep. Following deep sleep, the sleep cycle moves into REM sleep, which typically begins about 90 minutes after falling asleep. This stage is characterized by rapid eye movements, increased respiration rate, and brain activity that closely resembles being awake. However, the body's skeletal muscles become temporarily paralyzed. So REM sleep is essential for cognitive functions such as memory consolidation, learning, and problem solving. Dreams are most vivid during this stage because of the increase in brain activity. REM sleep is thought to support neuronal health and emotional regulation. Our body typically enters the first REM stage about 90 minutes after we've fallen asleep, and it might only last a few minutes, but REM stages get longer throughout the night and may actually eventually last around 1 hour. REM sleep makes up around a quarter of our total sleep duration each night. Each of these stages cycles throughout the night, typically in about 90-minute cycles with increasing duration of REM periods towards the morning. All right, with that brief sleep primer out of the way, let's talk about how alcohol has been shown to affect these various sleep stages as well as other aspects of sleep. The effects I'm going to talk about apply to a single acute dose of alcohol administered within a few hours before bedtime. When it's relevant, I'll specify if there are any dose-dependent effects. One of the most well-known and most robust effects of nighttime alcohol consumption is that it reduces the time it takes to fall asleep, which is also known as sleep onset latency. One of the reasons that many people drink alcohol close to bedtime is to help them fall asleep, despite the other negative effects that alcohol has on sleep. It is not a good sleep aid. Alcohol also increases the total amount of nighttime awakenings, in particular in the second half of the night. This is also known as wake after sleep onset. And it is one of the main ways that alcohol leads to more disrupted, less consistent sleep. What about the various sleep stages? Alcohol increases slow wave sleep at all doses, and this tends to occur in the first half of the night. Low doses of alcohol, about 1 to 2 standard drinks, don't appear to have a clear effect on slow wave sleep. However, moderate doses of alcohol, or 3 to 4 standard drinks, and high doses of alcohol, or more, which is more than 4 standard drinks, clearly increase total slow wave sleep during the night. This effect is consistent among gender and different age groups. You might be thinking that this is a good thing. Slow wave sleep or deep sleep is necessary for the recovery of our body and brain, right? While true, it is not necessarily the case that more deep sleep is better if you're already getting enough deep sleep. And certainly at that dose, you could be exposing yourself to brain volume loss and dementia risks. Importantly, slow wave sleep might increase at the expense of the also important REM sleep. At all doses, alcohol suppresses REM sleep during the first half of the night and also delays the onset of the first REM sleep period. This is perhaps the most notable effect of alcohol on REM sleep. At moderate and high doses of alcohol, total REM sleep during the night also decreases. Remember that REM sleep is crucial for long-term memory formation, and thus any amount of alcohol close to bedtime is likely to compromise this. So let's take a minute to recap. At all doses, when consumed an hour and a half or less from sleep, alcohol reduces sleep onset latency and increases sleep disruptions in the second half of the night. Alcohol also increases slow wave sleep or deep in the first half of the night, and at higher doses increases it during the whole night. Moderate and high doses of alcohol appear to reduce REM sleep, particularly during the first half of the night. Now, let's talk about alcohol timing. If you consume alcohol for 4 hours or more before sleep, the effects on REM sleep and REM sleep onset appear to be somewhat minimized, at least when compared to the same dose of alcohol consumed within 90 minutes of sleep. This does not mean that if you consume alcohol late in the afternoon, for example, that it will not affect your sleep. Even if breath or blood alcohol levels are 0 at bedtime, there's still some lingering effects of alcohol that include reduced sleep efficiency, total sleep time, stage 1, and REM sleep, as well as more wakefulness in the second half of the night. In other words, even if you consume alcohol in the afternoon, it's still possible it could negatively affect your sleep. There's one group of people who might really want to avoid alcohol prior to sleep, and those are people with sleep apnea. Obstructive sleep apnea is a condition that's characterized by repeated episodes of partial or total upper airway collapse or obstruction during sleep. This leads to dramatically slowed breathing or a complete stoppage of breathing during the night that can reduce oxygen delivery to the brain. Alcohol can worsen sleep apnea because it reduces muscle tone in the gena aglacis muscle. This is the muscle that helps keep our tongue protruded and prevents it from blocking our airway. When this muscle relaxes, the tongue can fall back and impair breathing, leading to apneic episodes during sleep. Higher alcohol consumption and consuming alcohol closer to bedtime may worsen these effects in two ways: by causing greater muscle relaxation and by reducing our sensitivity to episodes of apnea. Sleep apnea is much more common in heavy users of alcohol compared to non-users or less frequent users. A meta-analysis of 21 observational studies found that the risk for sleep apnea was 25% higher in those who consumed alcohol compared to those who didn't, and in people who consumed higher compared to lower amounts of alcohol. If you have sleep apnea, you're definitely going to want to avoid alcohol close to bedtime. But even for people without sleep apnea, alcohol could lead to sleep apnea-like episodes during the night that will negatively affect your sleep quality. Now I want to answer some of the few most popular questions that were submitted regarding alcohol and sleep. By far, one of the most popular questions was how to reduce the negative effects of alcohol on sleep. Many of you wanted to know how you could have a fun night out while enjoying a couple of drinks without waking up the next day feeling awful. Are there things you can eat or drink, supplements or supplement stacks you can take, or other lifestyle strategies you can engage in? Alcohol significantly impacts sleep architecture, particularly by disrupting later stages of REM sleep and increasing wakefulness in the second half of the night. To minimize these effects while still enjoying social occasions, timing and hydration may be key. Firstly, it's beneficial to stop drinking alcohol at least 3 to 4 hours before bedtime. This timing helps your body metabolize the alcohol before you enter the sleep period, though it's important to note that alcohol's effects can linger and disrupt sleep quality even if consumption stops early in the afternoon. Eating a substantial meal before or while you drink can also help slow the absorption of alcohol. This might buffer some of the immediate impacts on sleep. However, be mindful of not eating too late, as heavy meal right before bed can also disrupt sleep. Again, at least 3 hours before bedtime is ideal. Dehydration and electrolyte imbalance are significant ways that alcohol might affect sleep. Alcohol acts as a diuretic, increasing the production of urine and excretion of electrolytes like magnesium, which is important for sleep. Supplementing with electrolytes such as sodium, potassium, and especially magnesium might help counterbalance this effect. Magnesium glycinate is a good choice because it's bioavailable, and there's a lot of anecdotal evidence supporting its benefits for sleep, but there isn't really much evidence to support that this will improve your sleep if you've been drinking. One thing I would not advise is to mix melatonin with alcohol in an attempt to fall asleep or improve your sleep. There's strong likelihood that combining melatonin and alcohol will cause a large sedating effect. You should probably wait at least 3 hours before taking melatonin if you were drinking alcohol. I also think that many of the strategies that can help promote sleep in general also apply if you've been drinking. Try to keep your sleeping environment cool and dark and avoid bright lights and screens close to bedtime. Alcohol's effects on sleep are different from what is commonly called a hangover, even though sleep disruptions probably contribute to some hangover symptoms. So let's talk about hangovers. An alcohol hangover is defined as the combination of negative mental and physical symptoms which can be experienced after a single episode of alcohol consumption, starting when blood alcohol concentrations approach zero. Hangover symptoms are not due to alcohol intoxication. In other words, because they often occur the next day or after alcohol has been fully metabolized. We also need to distinguish alcohol hangover from alcohol withdrawal. Hangover is an acute phenomenon that appears after a night of drinking, but alcohol withdrawal occurs when someone who regularly drinks alcohol stops drinking and is due to several different neurochemical changes in the brain. Only people who've developed a tolerance to alcohol can experience withdrawal, but anyone can experience a hangover. Withdrawal symptoms are also more severe and can include anxiety, shaking, tremors, and sleeplessness. Traditional views on alcohol hangovers suggested that they only occur when blood alcohol levels reach a certain threshold, specifically around 0.11%, which is higher than the legal intoxication limit in many places of 0.08%. However, recent findings challenge this notion, indicating that hangovers can occur at much lower levels of alcohol consumption. The key factor isn't just the numerical value of blood alcohol concentration. Rather, it's about how intoxicated you feel, what we call the subjective level of intoxication, and how this amount compares to what you normally consume. The subjective experience can be more predictive of whether you're going to have a hangover than the actual amount of alcohol in your blood. This variation is due to several factors, including genetic differences in how we metabolize alcohol, variations in our body size, and differences in our usual drinking habits. For instance, someone who rarely drinks might experience a hangover after consuming just 1 or 2 drinks, whereas someone who drinks regularly might not feel the same effects. There does seem to be a genetic component to hangovers, and while the specific genes haven't been identified, it appears that genetic factors may account for up to 43% of being hangover resistant, which is defined as being able to consume alcohol without having a hangover. More than 47 symptoms of a hangover have been identified, but some of the most common are fatigue, thirst, drowsiness, headache, and problems with memory and concentration. People will also often experience an elevated heart rate, light and noise sensitivity, and muscle cramps during a hangover. Hangovers are a subject of much debate, particularly regarding their causes. Many people attribute hangovers to dehydration or electrolyte imbalances due to alcohol's diuretic effects, but recent studies suggest these aren't the primary culprits. While it's true that alcohol suppresses antidiuretic hormone, or ADH, leading to an increased urine production, the volume of fluids typically consumed with alcohol often compensates for this increase. So despite common beliefs, total body water balance might not be significantly impacted, and therefore, just drinking more water might not help with a hangover. When it comes to electrolytes, the evidence also suggests that alcohol intoxication only somewhat disrupts overall electrolyte balance, and it's likely contributing to the symptoms of a hangover, but is not the primary cause. However, what does occur is metabolic acidosis, a decrease in blood pH due to alcohol metabolism. Hangovers appear to be primarily driven by the metabolism of ethanol itself, which increases the production of reactive oxygen species. These molecules can cause oxidative stress in the mitochondria and the central nervous system, leading to an inflammatory immune response. This inflammation can manifest as nausea, vomiting, headaches, and cognitive impairments, symptoms commonly associated with hangovers. Indeed, levels of inflammatory markers such as IL-6, TNF-alpha, and C-reactive protein, as well as markers of oxidative stress, have been found to correlate with the severity of hangover symptoms. Hangovers also seem to be caused by the alterations in hormones and neurotransmitters, including GABA, glutamate, dopamine, and serotonin. Poor sleep quality probably contributes to some hangover symptoms as well, especially drowsiness, confusion, and trouble concentrating. Alcoholic drinks not only vary in their alcohol content, but also in their congener content. Congeners are chemical byproducts of the fermentation and distillation processes. They contribute to the taste, aroma, and color of alcoholic beverages. These substances include compounds like methanol, esters, tannins, histamines, and aldehydes. Drinks that are rich in congeners, such as brandy, red wine, rum, and whiskey, tend to produce more severe hangovers compared to drinks with fewer congeners like gin, vodka, tequila, and beer. The reason for this is partly biological. Congeners can enhance the inflammatory response in the body. They can compete with the metabolism of ethanol and prolong the processing of alcohol in the system, leading to a longer and more intense hangover symptoms. This inflammation can affect the brain and other systems, exacerbating the typical symptoms of a hangover, such as headaches, nausea, and overall malaise. However, it's important to understand that while congeners can influence hangover severity, the primary driver of a hangover is still the total amount of alcohol consumed. Drinking large amounts of any type of alcohol can lead to inflammation, dehydration, disturbances in electrolyte balance, and disruptions in sleep architecture, all of which contribute significantly to how you feel the next day. Sugar content in drinks, often thought to worsen hangovers, doesn't seem to play any significant role according to current evidence. So lastly, I'll talk about a topic that you probably all want to know about, and that is how to relieve hangover symptoms or prevent hangovers in the first place. I need to begin by saying that there is not a lot of good research here. Very few supplements or other strategies are effective for hangovers, and most of what I talk about is either anecdotal or speculative. No treatments have undergone systematic evaluation. There is fascinating research exploring how certain fruits might influence the metabolism of alcohol. This involves primarily the enzymes alcohol dehydrogenase and aldehyde dehydrogenase, which are crucial for breaking down ethanol and its byproduct, acetaldehyde, in the body. Studies conducted in vitro, which is in the lab, and in vivo, which is in living organisms, have shown that fruits such as pear, sweet lime, and coconut water, can enhance the activity of these enzymes significantly by about 20 to 90%. This suggests that these fruits could potentially speed up the breakdown of alcohol, thereby reducing hangover duration and severity. The authors propose that these fruits and their combination could represent an effective hangover product, but there is no human evidence to back this up. Further research has examined a variety of fruits for their effects on alcohol levels and liver health in animal models. For instance, fruits like the star fruit, the Chinese quince, yellow lemon, pear, and Java apple have demonstrated the ability to reduce ethanol levels in the blood. Interestingly, fruits such as yellow lemon, melon, the star fruit, and banana also showed protective effects against liver damage by reducing levels of liver enzymes AST and ALT, which are indicators of liver stress. The underlying mechanism for these effects appears to be linked to fructose, a type of sugar found in fruits. Fructose has been shown to accelerate the elimination of alcohol from the body by increasing metabolic activity. In human studies, consuming fructose was found to reduce the duration of intoxication by nearly 30% and enhance alcohol elimination by up to 44.7%. These findings suggest that consuming fruit or even some fruit juice, think cranberry and vodka, while drinking alcohol could theoretically help mitigate hangover symptoms or even some of the effects of sleep by enhancing the body's ability to process and eliminate alcohol more quickly. However, it is crucial to note that while these results are promising, they are preliminary, and more research, especially in humans, is needed to confirm these effects and to understand the optimal types and amounts of fruit that would be beneficial. Let's talk about vitamins and minerals. Understanding the relationship between micronutrient intake and hangovers reveals fascinating insights into how our body handles alcohol. Zinc and vitamin B3, also known as nicotinic acid, are two micronutrients that appear to have a significant impact on how we metabolize alcohol. Zinc is crucial for the function of several enzymes involved in alcohol metabolism, helping to break down alcohol more efficiently and potentially reducing the severity of hangovers. Similarly, vitamin B3 plays an important role in the enzymatic processes that convert alcohol into less harmful substances before they are cleared from the body. So therefore, higher intakes of these nutrients might correlate with less severe hangover symptoms. At least that is the correlation that has been found. Also remember that alcohol increases zinc excretion by up to twofold. So this is another reason to make sure you are replenishing your zinc stores while consuming alcohol. Let's now shift gears and talk about NSAIDs. So when it comes to managing hangover symptoms, not all common practices are advisable. For example, taking non-steroidal anti-inflammatory drugs known as NSAIDs like ibuprofen to prevent hangovers or to help with headaches can actually be counterproductive. These medications might slow down the enzymes that metabolize alcohol and its byproducts, potentially worsening hangover symptoms. More critically, acetaminophen, commonly found in Tylenol, should be avoided with alcohol as it can lead to increased liver toxicity due to enhanced metabolism when alcohol is present. As for the old adage, a hair up the dog or drinking more alcohol to cure a hangover, this is a myth that does not hold up under scientific scrutiny. Consuming more alcohol in the morning only delays the inevitable hangover symptoms and can increase overall toxicity in the body. This approach should be avoided as it can exacerbate the negative effects of alcohol. Many of you had questions about two supplements, liposomal glutathione and N-acetylcysteine, so let's talk about them. Alcohol consumption has a well-documented impact on reducing glutathione levels in various organs, including the liver, which is crucial for detoxifying harmful substances in the body. Glutathione is a potent antioxidant that helps neutralize free radicals, thereby protecting cells from damage. When you drink alcohol, the demand for glutathione in the liver goes up as the body works hard to metabolize alcohol and combat the oxidative stress alcohol generates. However, chronic or excessive drinking can deplete glutathione, leaving cells more vulnerable to damage from free radicals and other toxic byproducts of alcohol metabolism like acetaldehyde. This depletion might contribute to the increased oxidative stress and inflammation observed after heavy alcohol consumption, which are key factors in the development of hangover symptoms. Some animal studies and preliminary research have suggested that boosting glutathione levels either through direct supplementation or via precursors like N-acetylcysteine, or NAC for short, could help mitigate these effects. For example, studies in rats have shown that glutathione supplementation can reduce blood concentrations of alcohol and acetaldehyde, potentially easing hangover symptoms by enhancing the activity of alcohol metabolizing enzymes and exerting antioxidant effects. However, translating these findings to human applications has been challenging. While there is theoretical support that increasing glutathione levels could help manage alcohol-induced damage and hangovers, clinical evidence in humans remains sparse. A placebo-controlled study that tested N-acetylcysteine supplementation in humans found mixed results. Overall, N-acetylcysteine did not significantly reduce hangover symptoms, though some subgroup analysis did suggest potential benefits for women in terms of reducing symptoms like nausea and weakness. So N-acetylcysteine is the drug of choice for the treatment of acetaminophen overdose. It is thought to provide cysteine for glutathione synthesis and possibly to form an adduct directly with the toxic metabolite of acetaminophen. N-acetylcysteine might also reduce the toxicity of alcohol's metabolites. Similar to its interaction with acetaminophen toxic metabolites, N-acetylcysteine could theoretically react with acetaldehyde. It's the primary harmful metabolite of alcohol, and this reaction could form less harmful substances that are easier for the body to eliminate. But there is not a lot of direct evidence that this happens, so it really does remain speculative. Glutathione is another substance that might help with alcohol metabolism. So like N-acetylcysteine, it's intended to increase glutathione levels in the body. The liposomal formulation could potentially enhance the absorption and efficacy of glutathione, providing better support for detoxification processes in the liver. But again, this is largely based on speculation and not solid evidence. Another possible way to increase glutathione is through sulforaphane supplementation, which has been shown in clinical studies to increase both plasma and brain glutathione levels. Alcohol also depletes brain glutathione levels as well. Several Found My Fitness members brought up a product called ZBiotics, which is marketed as a pre-alcohol probiotic drink that is supposed to reduce hangover symptoms after a night of drinking. ZBiotics is a genetically engineered probiotic bacteria that, once consumed, produces the enzyme acetaldehyde dehydrogenase, or ALDH, in your gut. You remember from our discussion on alcohol metabolism that our liver naturally produces ALDH, which can metabolize most of the acetaldehyde generated during alcohol metabolism. About 80 to 90% of alcohol metabolism occurs in the liver. However, before alcohol is absorbed in the bloodstream and metabolized into the liver, gut bacteria process some of it, about 10 to 20%, into acetaldehyde, which then stays in the gut. Our gut cannot process acetaldehyde like our liver can, and this can contribute to some of the negative symptoms associated with alcohol metabolism. With more ALDH enzyme in the gut, more acetaldehyde can be metabolized. Remember that acetaldehyde is one of the toxic byproducts of alcohol metabolism, so the hypothesis is that less acetaldehyde or faster acetaldehyde metabolism should result in fewer hangover symptoms, but this doesn't appear to be entirely true. Although a faster metabolism of ethanol into acetaldehyde is associated with having less severe hangover symptoms, there's no evidence that a faster elimination of acetaldehyde, which hangover products like ZBiotics claim to promote, is effective for reducing hangover severity. Now, this doesn't mean that ZBiotics doesn't work. I'm just not aware of any randomized controlled trials that have tested ZBiotics or other similar products. However, some people who possess an alternative form of a gene known as aldehyde dehydrogenase 2, which makes them slower at metabolizing acetaldehyde, report experiencing worse hangover symptoms and experience hangovers at a lower level of alcohol consumption, which is some indirect evidence that modifying the activity of acetaldehyde metabolizing enzymes could affect hangover symptom severity. I do not have any affiliation with ZBiotics, and I haven't even tried the product personally, so it's hard for me to give a recommendation here, especially since there's no published evidence. All I'll say is that it seems like something worth trying if you're willing to spend the money on a pre-alcohol probiotic drink that may or may not work for you. A few Found My Fitness members also mention a supplement called Dihydromyricetin, or DHM, which is a flavonoid compound that's derived from the Chinese herbal medicine. And it's something that has been used as an anti-hangover remedy for centuries, and it's a very common ingredient in commercial hangover remedies. Originally, it was thought that DHM reduced hangover severity by increasing the rate of alcohol metabolism, but some newer evidence in rodents suggests another mechanism might be at play. DHM does reduce alcohol intoxication and also decreases signs of alcohol withdrawal and reduces voluntary alcohol consumption. The mechanism seems to involve the ability of DHM to counteract the effects of alcohol on GABA receptors in the brain, which are known to play a role in the development of alcohol tolerance and alcohol use disorder. For this reason, DHM has actually been proposed as a treatment for alcohol use disorders, even though there's not currently any strong human evidence to support its use. Two other strategies that I think should at least help people feel better after consuming alcohol are exercise and sauna, though I'll mention that I do not think either of these negates the toxic effects of alcohol in the body. Anecdotally, exercise and sauna can help you feel more energized and less lethargic if you're hungover, but not because you're sweating out the alcohol. But hydration and electrolyte replenishment are important here as you lose water and electrolytes via sweat. Though you might not feel like exerting yourself much after a night of drinking, breaking a sweat may lift your mood by increasing endorphins, enhancing blood flow and metabolism, and overall promoting relaxation and reducing anxiety that you might be experiencing during a hangover. Let's summarize the evidence on hangover remedies. Currently, there is no strong human evidence to support any one hangover cure. The most important thing seems to be to moderate your alcohol intake or avoid it altogether. But if you want to try out some hangover remedies, I think there's at least some support that liposomal glutathione, N-acetylcysteine, sulforaphane, eating a meal with fruit, and hydrating with electrolytes may help mitigate some symptoms. Now, I want to pivot our conversation into talking about alcohol's effect on health and disease, beginning with alcohol's effect on longevity and aging. Let's be clear from the start, harmful use of alcohol is responsible for more than 200 different disease and injury conditions. In 2016, there were 3 million deaths attributed to alcohol, or around 5.3% of all deaths worldwide. Alcohol is also estimated to be responsible for 131 million years of life loss due to premature mortality, or years of healthy life loss due to disability and disease. Alcohol's effect on mortality risk is greater than that for tuberculosis, HIV and AIDS, diabetes, hypertension, digestive diseases, road injuries, and violence. Men seem to have a higher alcohol attributable burden of disease than women. Furthermore, the risks of alcohol aren't just for older people. Even in adults aged 20 to 39, approximately 13.5% of all deaths are attributable to alcohol, and over 50% of all alcohol-related deaths occur in adults younger than 60. Like all drugs, when misused, alcohol can cause harm. What's more relevant to most people is how a low-risk drinking habit impacts health span and lifespan. That's what I'm going to cover now. One extensively adjusted meta-analysis of over 4.8 million participants did not find any significant association between consuming less than 1 to up to 3 drinks per day with all-cause mortality when compared to lifetime non-drinkers. People consuming 3 to 5 and more than 5 drinks per day, who the study characterized as high volume and highest volume drinkers, had a 19 to 35% greater mortality risk than lifetime non-drinkers. However, the risk was different for men and women. Mortality risk was higher in women than in men and increased even among women having 2 or more drinks per day. In men, mortality risk increased at 3 or more drinks per day. Metabolic differences, body composition, and hormonal factors can cause alcohol to have different impacts on men and women. Women generally have lower gastric levels of the enzyme alcohol dehydrogenase, which helps metabolize alcohol, making them more susceptible to alcohol's effects at lower doses compared to men. This could explain the increased mortality risk in women compared to men. An important advancement from this study was the finding that while low to moderate volume drinking didn't increase mortality risk compared to abstaining, it didn't provide protection either, as has been suggested by previous large-scale studies. So, Some studies have found a lower life expectancy in so-called low and moderate drinkers. A study involving nearly 600,000 current drinkers has shown that even what many consider low to moderate levels of drinking can significantly decrease life expectancy. For example, individuals consuming about 8 drinks per week might see a reduction in life expectancy by around 6 months by the age of 40, compared to those who drink 4 or fewer drinks per week. As the number of drink increases to 15 and then to 26 drinks per week, the reduction in life expectancy becomes more pronounced, potentially decreasing by 1 to 2 years and 4 to 5 years, respectively. Similar results are observed for health span. The lowest risk is observed at 0 alcoholic drinks per day, but is still non-significant up to 10 standard drinks per week, or less than 1 drink per day. But above 1 standard drink per day, there's a steady increase in mortality risk. I think it is safe to say here that there is no amount of alcohol that increases life expectancy, and it appears at least consistent across several studies that up to 4 drinks per week is not associated with a decrease in life expectancy compared to abstaining from alcohol. A few Found My Fitness members had questions about the blue zones and why in these countries where people tend to have exceptional longevity, moderate alcohol consumption is typically a large part of the culture. So-called blue zones are areas of the world that have an unusually high number of people who are the oldest of the old, which typically refers to centenarians or people who are 100 years or older. Okinawa, Japan, Sardinia, the Greek island of Icaria, Loma Linda, California, are 4 blue zones that have been identified and well characterized. It does appear that people in these regions, other than the Seventh-day Adventists of Loma Linda, drink alcohol regularly but moderately, about 1 glass of wine per day. This is important because in addition to the amount of alcohol consumed, the pattern of consumption likely matters. Drinking 1 glass of wine per day is probably different than drinking 7 glasses of wine on Saturday, even if patterns lead to an average of 7 drinks per week. A low to moderate daily dose characterizes the drinking patterns of the blue zones. People in these areas also tend to consume wine with meals, which may also be an important factor. For example, men and women in Icaria drink more alcohol than people living in other parts of Greece, and 75% of Icarians reported drinking 1 to 2 glasses of red wine daily. The fact that most of the alcohol consumed in the blue zones is red wine and is probably important to note, given that red wine has been speculated to promote health span and longevity due to its high content of polyphenols and other bioactive compounds, even though this is somewhat disputed, and we talked about the low levels of polyphenols such as resveratrol in red wine. Among residents of Okinawa, more men and women report moderate daily drinking compared to the general Japanese population. It's also interesting that many long-lived people from the blue zones are former smokers, even though few of them are active smokers. This is one explanation for the exceptional longevity of people in the blue zones. They might be particularly good at dealing with toxins such as those present in alcohol and cigarettes. This would indicate that people in the blue zones don't live long because of their moderate daily alcohol intake, but in spite of it. Adopting the drinking habits of people in the blue zones probably won't allow you to live as long as them, at least not if you don't have the right genes. One gene known as FOXO3A or FOXO3A has consistently been associated with human longevity. FOXO3A has a protective role against oxidative stress and is involved in apoptosis, DNA repair, immune cell regulation, carcinogenesis, and stem cell maintenance. Having a protective allele of this gene, or the TT genotype, could explain why people in the blue zones live longer despite their moderate alcohol consumption. But some studies fail to find differences in the prevalence of the protective allele of FOXO3A genes among blue zone populations like those in Sardinia compared to other Italians and Greeks. I find it hard to believe that longevity in the blue zones is because of direct effects of moderate red wine consumption on health. The social aspects that are associated with moderate alcohol consumption with meals may provide an indirect benefit to health and longevity by improving well-being by reducing stress. That is probably really just the extent of it. So to summarize, there's really no evidence that any amount of alcohol has any positive effect on life expectancy or health span. Even levels of alcohol consumed regularly by a large portion of the population appear to increase the risk of death and disease, and the risk isn't limited to those in older age. To optimally reduce your health risks, abstaining from alcohol is recommended, but if you choose to drink, a safe amount for most healthy individuals appears to be 1 to 2 drinks per week on average, without exceeding 5 drinks per week, as this level of alcohol consumption does not appear to increase mortality risk compared to abstainers. Finally, while the moderate drinking habits characterized of the blue zones are associated with longevity, it's probably not due to a direct benefit of alcohol or red wine, but rather the social aspects that are related to this pattern of alcohol consumption. Examining the association of alcohol intake with mortality can tell us a lot about how alcohol affects life expectancy of the general population, but it's also useful to assess disease-specific mortality rates so that we can make informed decisions about drinking habits in the context of our own unique health conditions and genetic predispositions. This is particularly relevant in the context of cancer. With that in mind, it's time to talk about alcohol and cancer. Epidemiological evidence has implicated alcohol as a cause of cancer. Alcohol consumption is associated with a higher risk for oropharyngeal cancer, laryngeal cancer, esophageal cancer, liver, colon, rectal, and breast cancer. Importantly, risk increases in a dose-response fashion, and there is no apparent evidence of a threshold effect. In other words, the more alcohol you drink, the greater your risk for these cancers are. Understanding the influence of lifestyle factors on cancer risk requires knowledge of the cancer's average lifetime risk. For cancers with relatively high lifetime risks, like breast cancer in women, even a small increase in risk can be significant. The average lifetime risk for breast cancer in women is about 1 in 8, meaning that lifestyle factors that slightly elevate this risk are important to consider because of the cancer's already high baseline prevalence. Conversely, cancers with a lower lifetime risk, like esophageal cancer in women, which only has a risk of 1 in 455, might not see such a dramatic impact from lifestyle changes on an individual level. However, it's crucial to recognize that lifestyle factors, including obesity, smoking, they can also significantly affect the average lifetime risk of various cancers. So while the absolute increase in risk might be smaller for some less common cancers, the relative increase can still be meaningful, especially when considering the population's health at large. With that said, very light drinking, defined as less than half of a standard drink per day, or less than around 5 standard drinks per week, increases the risk of breast cancer by around 4%. In contrast, the risk of other cancers doesn't appear to be significantly elevated. This 4% increased breast cancer risk elevates the average lifetime risk for women for breast cancer from 1 in 8 to approximately 1 in 7.7. While this appears to be a modest rise, it's important to evaluate it in the context of already a high baseline risk of breast cancer. Light drinking, defined as less than an average of 7 drinks per week, increases the risk for breast and colorectal cancer by around 4 and 9%. Oral and pharyngeal cancer by 13 to 17%, and esophageal and malignant melanoma by 26 to 44%. Since these are relative risks at the population level, let's look at how this affects people on an individual level. For instance, consuming fewer than 7 drinks per week raises a woman's lifetime risk of breast cancer from around 1 in 8 to 1 in 7, which is meaningful, particularly in the context of other risk factors like obesity, genetics, family history. Meanwhile, the average lifetime risk of oral cancer in the United States for both men and women is approximately 1 in 60. This risk increases to about 1 in 51 for those consuming fewer than 7 drinks per week. And while alcohol consumption appears to have a dramatic effect on esophageal cancer, the lifetime risk for this cancer is higher in men than in women. The risk for men in the United States is about 1 in 132, while for women, it's around 1 in 455. That means the lifetime risk escalates between 1 in 316 for women and up to 1 in 92 for men. Moderate drinking, defined as consuming an average of 1 to 3 drinks per day, significantly impacts the risk of developing several types of cancer, which increases ranging from 12% to 123% depending on the cancer type and the individual's baseline risk. For example, the risk of oral, pharyngeal, and laryngeal cancers in men might rise from a baseline risk of approximately 1 in 60 up to 1 in 27. Women, starting from a lower baseline risk, about 1 in 140, could see their risk increase up to 1 in 63. Colorectal cancer risk in men could climb from 1 in 23 up to 1 in 10. While for women, the baseline risk for colorectal cancer is 1 in 125, and that might go up to 1 in 11. For breast cancer affecting women predominantly, the risk can surge from 1 in 8 up to 1 in 4. Lastly, liver cancer risk for men may jump from 1 in 81 up to 1 in 36. And for women, from 1 in 196 up to 1 in 88. I just want to take a moment to say that even 1 drink per day can be considered moderate alcohol consumption. This could be extremely risky for both men and women because of the dramatic increases in 2 very common cancers, breast and colon cancer. Finally, heavy drinking, defined as more than 3 drinks per day, is associated with a drastic increase in the relative risk for most cancers, ranging from 15 to 21% for lung and stomach cancers to over 300 to 400% for esophageal, pharyngeal, and oral cancers. Again, I want to mention that several of these studies do not adjust for the sick quitter or abstainer bias, so the risk may even be underestimated in people who developed cancer and stopped drinking. I also want to take another moment just to consider globally how many people do consume 1 or 2 alcoholic beverages daily, which is considered moderate drinking. But as I just mentioned, it's crucial to recognize the associated increased risk in breast and colorectal cancers, which are very significant. Breast cancer is the most prevalent form of cancer worldwide, and colorectal cancer ranks 4th. From a cancer prevention perspective, there truly is no completely safe level of alcohol consumption. For those seeking a compromise and who are generally healthy with no family history of or cancer or genetic predispositions to breast and colon cancer, limiting alcohol intake to about 2, maybe 3 drinks per week would be a more prudent approach. I think this level minimizes the risk while acknowledging social and cultural practices around alcohol. Is alcohol just as bad as cigarette smoking for cancer risk? If so, how bad? One study actually looked at the cigarette equivalent of cancer harm due to alcohol intake, finding that about 5 standard drinks per week was roughly equal to smoking 4 to 5 cigarettes per week for men and 10 cigarettes per week for women in terms of its impact on absolute lifetime cancer risk. Hazardous drinking carried the same risk as smoking 8 cigarettes per week for men and almost an entire pack per week for women. Many people may be curious about whether the pattern of drinking affects cancer risk. Specifically, is it riskier to consume a week's worth of alcohol in 1 or 2 days compared to spreading it out over the week? Research on this is limited because studies typically average alcohol consumption. So for instance, someone who drinks 7 drinks on a Friday would be recorded as consuming 1 drink per day, and therefore it's considered to be a moderate drinker, even though they engage in binge drinking once per week. The evidence suggests that for those who drink in low to moderate amounts, the pattern of drinking, whether it's spread throughout the week or concentrated on fewer days, does not significantly change the overall cancer risk. Even heavy episodic drinking, which is defined as consuming more than 6 drinks on one occasion, did not show an increased cancer risk after accounting for total weekly alcohol intake. However, the frequency of drinking can affect the risk of certain cancers. For example, more frequent drinking has been linked to a higher risk of gastrointestinal cancers. Additionally, women who consume more than 14 drinks per week have a higher risk of breast cancer if those drinks are concentrated on fewer days, so 1 to 3 days per week, rather than spread out over 4 to 7 days. This pattern was not observed with other types of cancer, such as colorectal, lung, and prostate cancers. So in summary, while overall alcohol consumption is a crucial factor in cancer risk, the frequency And the concentration of drinking sessions also play a significant role, particularly with specific types of cancer like breast cancer. Certain genetic factors may also influence alcohol-associated cancer risk. Having just one copy of the low alcohol tolerability allele for the enzyme alcohol dehydrogenase increase the risk of cancer in men, but only among regular drinkers and not non-drinkers or abstainers. A few studies in Asian populations found elevated cancer risk in moderate and heavy drinkers who carry genetic variants associated with less activity of the alcohol metabolizing enzymes, alcohol dehydrogenase and aldehyde dehydrogenase. And those with both variants had a higher cancer risk than those with just one, but only in heavy drinkers, suggesting an interaction between genes and alcohol consumption patterns on cancer risk. A common mutation in the methylene tetrahydrofolate reductase, or MTHFR, a key enzyme involved in the metabolism of folate, may also play a role in cancer risk related to alcohol. People with the TT or CT genotypes have 1 to 2/3 lower MTHFR activity compared to people with the CC genotype. Interactions between heavy drinking and the MTHFR TT or low activity genotype have been reported for head and neck and esophageal and colorectal cancers. Finally, carriers of a variant allele of the peroxisome proliferator activated receptor gamma, or PPARG2, had a 20% increased risk in their breast cancer for every 10-gram increase in daily alcohol consumption, or just under 1 standard drink per day. So while a few genes seem to influence cancer risk associated with alcohol intake, there's a lot to learn in this area. I want to take a moment to talk about well-known gene variations that affect breast cancer risk. We discussed how the average lifetime risk of breast cancer for women is often quoted as 1 in 8, but this figure can be dramatically altered by genetic factors. Specifically, variations in the BRCA1 and BRCA2 genes can significantly increase this risk. For women with a BRCA1 variant, the lifetime risk of developing breast cancer can increase to between 55% and 72%, which translates to a lifetime risk of about 1 in 1.8 at the lower end and 1 in 1.4 at the higher end. Meanwhile, BRCA2 variant carriers face a lifetime risk of 45% to 69%, which is equivalent to about 1 in 2.2 or 1 in 1.45. So, these dramatically elevated risks really underscore the critical importance of genetic testing and counseling for those with the family history of breast cancer. Even a very small amount of alcohol would increase these risks even further. Another important question to consider is whether the risks of developing cancer decrease after alcohol intake is stopped, and whether cancer risk ever returns to baseline levels in former drinkers. Many of the meta-analyses on cancer risk after quitting alcohol have focused on head, neck, and esophageal cancer. In short, quitting alcohol doesn't immediately reduce the risk of these cancers. It may take years for the risk to fall to levels observed in people who have never consumed alcohol. For example, it takes 15 years of abstinence for the risk of esophageal cancer to fall by 63% in former drinkers, and up to 16 years for the risk of head and neck cancer to fall by about 33% compared to current drinkers. It may take about 20 years for the risk of these two cancers to equal that of never drinkers. For certain cancer types, including laryngeal, pharyngeal, and liver cancer, each year without alcohol is associated with a 2 to 7% risk reduction compared to active drinkers. Overall, it does appear that to reach cancer risk levels equal to those of a never drinker, it can take between 20 and 35 years or more, depending on the type of cancer. For example, the risk of laryngeal and pharyngeal cancers doesn't return to levels of never drinkers until 36 and 39 years after quitting. But the good news is that the risk eventually does fall and may decline by a small bit each year without alcohol. The only exception to this appears to be in the first 1 to 2 years after quitting, where the risk for certain cancers, including esophageal cancer, actually spikes by up to 150%. This might be explained by the sick quitter phenomenon. People stop drinking alcohol only after they felt symptoms, or other health effects, and thus recent abstainers have a high risk compared to current drinkers and those who have stopped drinking 2 years or longer. So finally, I want to talk about some cancer mechanisms by which alcohol may increase cancer risk. So ethanol is recognized as a Group 1 carcinogen by the International Agency for Research on Cancer, and it has been for decades. Group 1 is the highest risk group and includes other known carcinogens like asbestos, radiation, and tobacco. So acetaldehyde is produced during metabolism of alcohol, and it can directly cause DNA damage and prevent DNA repair processes. So when acetaldehyde binds to DNA, it forms DNA adducts that cause mutations, double-stranded breaks, and other chromosomal changes. Acetaldehyde can also bind and affect the structure and function of proteins involved in antioxidation and DNA repair. Ethanol induces oxidative stress by elevating levels of reactive oxygen species, which also have DNA damaging effects. This likely occurs during the oxidation of ethanol to acetaldehyde. It's a process that generates reactive oxygen species because of elevated activity of the enzyme known as CYP2E1. This enzyme has been shown to increase in heavy alcohol users. Reactive oxygen species are also produced from the mitochondrial respiratory chain and other cytosolic enzymes during alcohol metabolism. Another cancer-causing mechanism of alcohol involves inflammation. The chronic consumption of alcohol can recruit immune cells known as monocytes and macrophages to the tumor microenvironment. The tumor microenvironment refers to a complex ecosystem surrounding the tumor that is composed of cancer cells, stromal tissue, and extracellular matrix. These immune cells can produce pro-inflammatory cytokines, including tumor necrosis factor alpha or TNF alpha, interleukins, IL-1, IL-6, IL-8. These pro-inflammatory cytokines lead to reactive oxygen species generation, which then contributes to the oxidative stress that can cause DNA damage and potential cancer-causing mutations. Alcohol can disrupt immune function, particularly the function of proteins that are essential for the activity of natural killer cells that have anti-cancer properties. This weakened immunity against tumors appears to involve alcohol's effect on hindering natural killer cell release from bone marrow, the activation of natural killer cells that cause liver injury and also suppress T-cell response. Altered hormone levels may also explain the role of alcohol in cancer development, and here there is a particular relevance to breast cancer. Alcohol appears to increase the levels of estrogen and enhance the activity of estrogen receptors that play a role in breast cancer development. Notably, estrogen receptor activity may increase by up to 15 times higher than normal with alcohol use, with alcohol being more strongly associated with estrogen receptor positive breast tumors. There are a few more mechanisms that haven't been as well studied, but that still deserve attention. The first of these involves gut dysbiosis. Ethanol intake can cause the overgrowth of certain bacteria in the intestine, and these bacteria then compromise the lining of the intestinal barrier, leading to something known as intestinal permeability, also commonly referred to as leaky gut. If the intestinal barrier is permeable enough, bacterial products, including lipopolysaccharide and peptoglycan, can enter the blood. They can reach the liver, and they could lead to a pro-inflammatory environment. This mechanism may have particular relevance for liver cancer. Also, as discussed earlier in this episode, alcohol can interfere with our ability to break down and absorb key micronutrients, including vitamin A, vitamin B1, vitamin C, vitamin D, folate, selenium, zinc, and magnesium. All of these micronutrients have been identified as having certain cancer preventative properties. So the potential for alcohol to cause deficiencies or even insufficiencies in these micronutrients is a major concern. Lastly, alcohol products contain several contaminants that are introduced during the process of fermentation and production. These include nitrosamines, asbestos fibers, phenols, hydrocarbons, all of which are recognized as being carcinogenic. Although this probably doesn't need to be emphasized, the worst thing that you can do is use both alcohol and tobacco. There is a well-recognized interaction between drinking and smoking for cancers of the mouth, pharynx, larynx, and esophagus. According to the World Health Organization, the risk for these cancers is up to 30 times greater in people who use alcohol and tobacco compared to users of alcohol alone or tobacco alone. The use of both substances is especially carcinogenic, likely because alcohol acts as a solvent for other carcinogenic compounds found in tobacco, such as formaldehyde, facilitating their absorption into cells of the mouth and throat. Combining alcohol and tobacco may also overwhelm the body's anti-cancer defense mechanisms, making it more likely for a tumor to develop. Avoiding combining these two factors is really important. All right, I think it's time to wrap up our discussion on alcohol and cancer with a few take-home messages. Any amount of alcohol appears to increase cancer risk, with moderate and heavy drinking increasing risk more than light drinking. This means that overall, the less alcohol you consume, the lower your overall cancer risk appears to be. However, if we look at cancer with a low lifetime risk, such as esophageal cancer in women, where the lifetime risk is about 1 in 455, the increase in risk associated with light alcohol consumption might not be that big of a deal. On the other hand, for breast cancer in women, where the average lifetime risk is 1 in 8, there's probably no safe level of alcohol consumption because the baseline risk of this cancer is so high, and any increase carries significance, especially if you're genetically predisposed to breast cancer. It's important to understand that the risk of cancer due to alcohol will vary widely from person to person, depending on family history, genetic risk, and other lifestyle factors such as obesity, being sedentary. Each of us has to make our own risk assessment when it comes to deciding what amount of alcohol is safe. For some, that might be 0. In light of all the evidence we've just discussed, a reasonable approach for most people would be to limit alcohol consumption to about 2, maybe 3 U.S. standard drinks per week to minimize cancer risk, even for those who don't have known risk factors. Next, I'd like to talk about alcohol and cardiovascular disease. This is an area where the research has been somewhat mixed. It was once and is sometimes still believed that small to moderate amounts of alcohol, up to about 7 drinks per week or less than 1 drink per day, actually had a protective effect against cardiovascular disease compared to not drinking. Studies on the relationship between alcohol and cardiovascular disease sometimes show a U-shaped relationship, meaning that at very low and very high levels of alcohol consumption, cardiovascular disease risk increases, but at moderate levels of consumption, risk decreases. The data here are sometimes difficult to analyze because studies vary in how they define different levels of drinking. But for the purpose of our discussion, we will use a definition of moderate drinking that is most often reported in the literature, which is 1 to 2 standard drinks per day for men and women, whereas heavy alcohol consumption is 4 or more drinks per day. The evidence showing moderate alcohol consumption has a protective effect on cardiovascular health was shown to be biased by the so-called sick quitter effect discussed earlier, which has caused many researchers to rethink the positive effects of alcohol on cardiovascular health. Remember that the sick quitter effect occurs when former heavy alcohol drinkers who have quit using alcohol are misclassified as non-drinkers in a study. This may bias the non-drinkers or abstainers to be less healthy than the moderate drinkers due to the fact that they're former heavy drinkers. So, the studies that haven't accounted for the sick quitter bias often show a U-shaped relationship between alcohol consumption and total cardiovascular disease risk. But this is probably an overestimation of the protective effects of moderate drinking. Let's talk about why. When studies take into account the sick quitter effect and more rigorously classify the participants based on their alcohol use status, different results emerge that suggest the safe level of alcohol consumption for cardiovascular disease may be lower than once estimated. For example, when former drinkers are removed from the abstainer category, the lowest risk for cardiovascular disease, specifically ischemic heart disease, appears to occur right below 1 standard U.S. drink per day. This is associated with a 17 to 18% lower relative risk among men and women when compared to non-drinkers. In a comprehensive analysis involving nearly 600,000 participants, a clear dose-response relationship was observed between alcohol consumption and several types of cardiovascular diseases. This means that as alcohol intake increases, so does the risk for diseases such as stroke, coronary disease, heart failure, fatal hypertensive disease, and fatal aortic aneurysm. Specifically, for each increase of 100 grams of alcohol per week, equivalent to about 7 standard U.S. drinks, the risk for these cardiovascular diseases increases by between 6% and 24%. Interestingly, this same study found that increasing alcohol consumption slightly decreased the risk of myocardial infarction or heart attack by about 6% per 100 grams of alcohol per week. This paradoxical finding suggests that alcohol's effects on the cardiovascular system are complex and can vary significantly depending on the specific condition or outcome being examined. The study also noted that the lowest risk for all-cause mortality and most cardiovascular diseases was observed at around 7 drinks per week. Beyond this amount, no additional protective effects were seen, and importantly, lower alcohol intakes did not provide more benefits. This challenges the widely held belief that moderate alcohol consumption is broadly protective against cardiovascular disease. It is crucial to recognize that these findings debunk the simplistic view of a J-shaped curve commonly described in earlier studies, where moderate alcohol consumption was thought to universally benefit cardiovascular health. Instead, the effects of alcohol are specific to the type of cardiovascular disease, underscoring the need to think critically about the distinct ways alcohol influences different aspects of cardiovascular health. This study is particularly robust because it only included current drinkers, thus eliminating the potential bias from sick quitters. I also want to discuss one more study that helps us understand alcohol's impact on the cardiovascular disease risk and how we should think about our own alcohol consumption patterns. In a 2020 meta-analysis examining the impact of alcohol on cardiovascular disease, researchers found that moderate alcohol consumption, defined as up to 40 grams of alcohol per day, which is roughly equivalent to about 3 standard U.S. drinks, showed a protective effect against cardiovascular diseases such as coronary heart disease and stroke. But interestingly, this effect was observed only in men. When data for men and women were analyzed together, the results indicated no clear dose-response relationship. This means that across the combined group, there wasn't a consistent pattern showing that increasing amounts of alcohol reduced the risk of cardiovascular disease, nor was there a clear indication that higher amounts of alcohol necessarily increase the risk, even among heavy drinkers consuming between 4 to 8 drinks per day. Furthermore, the study also highlighted that no protective effects were found in individuals with 3 or more comorbid conditions like high blood pressure, diabetes, and dyslipidemia, nor among participants younger than 40 years old. It's crucial to note that some of these observations may stem from limitations in the available data, as no studies were found that specifically address these subgroups within the meta-analysis. My interpretation of this study is similar to insights gleaned from our discussion on cancer, that alcohol affects everyone differently based on a myriad of individual factors. For instance, the study suggests that in men without significant health issues, consuming up to 40 grams of alcohol per day, which is about 3 standard U.S. drinks, might actually be associated with a reduced risk of cardiovascular diseases such as coronary heart disease and stroke. But remember, this same quantity of alcohol was associated with an increased risk for certain cancers. So it's critical to recognize that this protective level of consumption doesn't apply universally to all diseases. In contrast, for women, younger adults under 40, and individuals with multiple comorbidities such as high blood pressure, diabetes, dyslipidemia, no amount of alcohol consumption has been found to reduce the risk of cardiovascular diseases. In fact, for these groups, any level of alcohol intake could potentially contribute to an increased risk of cardiovascular disease. Moreover, the situation becomes more concerning for men with 3 or more comorbid conditions. In these cases, consuming between 4 to 6 standard U.S. drinks per day could nearly double the risk of developing cardiovascular disease. This really highlights the significant role that personal health status and existing conditions play in mediating the effects of alcohol on the body. Now, I do want to talk a little bit about the mechanisms that might link alcohol to cardiovascular disease, including acute and chronic effects of alcohol consumption. Chronic alcohol consumption can directly affect the small blood vessels, the microvasculature that supply the blood and oxygen to the heart. This leads to what's termed as the remodeling of microcirculation, which includes disorganization of the vessel wall layers, swelling, and the development of fibrosis and tissue scarring. These changes are accompanied by inflammation and degeneration of endothelial cells, which line the inside of these vessels. While some evidence for these effects comes from observational studies of heavy, long-term alcohol users, animal studies also support these findings, showing similar detrimental changes to endothelial structures and functions as a result of alcohol exposure. Alcohol consumption can also disrupt the normal function of endothelial cells and the baroreflex, which helps regulate blood pressure, as well as activate the sympathetic nervous system, which typically responds to stress. Alcohol increases oxidative stress and affects hormonal systems like the renin-angiotensin-aldosterone system, crucial for fluid balance and blood pressure regulation. Interestingly, the relationship between alcohol and blood pressure might be biphasic, meaning at lower doses, alcohol may actually enhance the activity of enzymes that produce nitric oxide, a molecule that aids in regulating vascular tone and improving endothelial function, thereby offering some cardiovascular protection. However, higher doses reverses these benefits, elevating blood pressure and cardiovascular disease risk. Several other mechanisms linking alcohol and cardiovascular disease may also have dose-dependent effects. For example, low to moderate alcohol consumption appears to raise HDL cholesterol levels and lower LDL cholesterol and triglycerides. It improves insulin sensitivity and reduces the levels of factors that promote blood clotting and platelet aggregation. On the other hand, binge drinking or heavy alcohol consumption worsens these risk factors. Acutely, alcohol consumption increases the risk for heart arrhythmia, known as atrial fibrillation or AFib. And binge drinking, defined as consuming more than 5 drinks on a single occasion, appears to be the most risky for AFib. Intoxicating doses of alcohol also weaken the heart's ability to contract. A final mechanism that I want to discuss is oxidative stress because it is very likely to be implicated in alcohol-induced cardiovascular diseases. Alcohol metabolism generates free radicals and ethanol and can directly impact the activity of antioxidant proteins and enzymes, as we have already discussed. This means that our body will produce more free radicals and have a lower ability to protect the heart against them due to impaired antioxidant defense systems that occur shortly after drinking alcohol. In addition to their effects on the heart tissue, reactive oxygen species can induce mitochondrial dysfunction and impair mitochondrial energy metabolism and production. Several of the mechanisms discussed earlier, including inflammation, fibrosis, and endothelial dysfunction, can be attributed to oxidative stress. It may be the mechanism that ties together heavier alcohol consumption and the risk for cardiovascular diseases. In the most extreme cases, chronic heavy alcohol use can lead to a condition known as alcoholic cardiomyopathy. This is a heart disease characterized by an abnormally large heart with dilated ventricles, but a poor ability to pump the blood. Most people presenting with this condition consume 6 to 8 drinks per day for 20 years or more, and low to moderate consumption of alcohol has not been linked to alcoholic cardiomyopathy, really underscoring the fact that the dose of alcohol and the duration of consumption are the most important factors in determining whether alcohol will elevate or have no impact on this risk. The dose really does seem to make the poison when it comes to cardiovascular disease. And the last thing I do want to talk about is the potential role of industry funding in the research related to alcohol and cardiovascular disease. An analysis published in 2021 that investigated the role of industry funding in alcohol research noted that almost 25% of systematic reviews, a total of 14 of 16 studies, had a known connection to alcohol industry funding. All of these reviews identified a cardioprotective or beneficial effect of alcohol. Among the studies with no ties to industry, only about 50% of them concluded that alcohol had health protective effects. Another notable finding was that the studies with industry funding were more likely to study broader outcomes like cardiovascular disease instead of more specific cardiovascular disease outcomes like stroke or hypertension. This does not mean that alcohol does not have a cardioprotective effect or that there's a sinister conspiracy among researchers to make us believe alcohol is healthy, but it does suggest we read the research with a healthy dose of skepticism. On that note, here are a few take-home messages. When it comes to cardiovascular disease, the risk appears to increase above a weekly dose of 7 to 14 drinks per week, what we previously defined as moderate alcohol intake. This level of drinking may not exactly be protective against the various cardiovascular diseases, but it may not significantly elevate risk compared to not drinking. The risk that alcohol has on other diseases like cancer likely outweighs any potential benefits for cardiovascular disease. As with all things, you need to consider the influence of other risk factors, including your sex, your race, your ethnicity, nutrition, and genetic risk for alcoholism or cardiovascular disease when making decisions about alcohol use. Let's transition now to talk about alcohol and metabolic health. This was another area where many of you had questions regarding alcohol's effect on blood glucose and how alcohol might affect fat metabolism and weight loss. We will get into all of that in this section. The connection between alcohol and the risk of developing type 2 diabetes presents an intriguing and somewhat inconsistent picture compared to alcohol's relationship with other diseases. Unlike many conditions where high alcohol consumption straightforwardly increase the risk, the association with type 2 diabetes appears to follow a U-shaped curve. For men, consuming about 1.5 drinks per day has been associated with a 13% reduction in the risk of developing type 2 diabetes compared to those who never drink. This protective effect diminishes and eventually becomes harmful at consumption levels exceeding 4 drinks per day. In women, the risk reduction is even more pronounced at 1.5 drinks per day, showing a 40% decrease in diabetes risk. However, this benefit reverses at higher levels, specifically beyond 3.5 drinks per day, where the risk begins to increase again. Another meta-analysis interestingly suggests that the lower risk for type 2 diabetes is maintained up to about 63 grams of alcohol per day, around 4 standard drinks, with the most significant risk reduction occurring at much lower levels, around 10 to 14 grams per day, or about 1 standard drink. However, these findings must be interpreted with caution. Many of the included studies did not adequately control for the sick quitter effect. Again, a bias that occurs when people who have quit drinking due to health problems and are included in the non-drinking group. This does potentially skew results to make current drinkers appear healthier. Furthermore, when only studies using lifelong non-drinkers as a comparison group were analyzed, the protective effect of alcohol on diabetes risk disappeared. This adjustment suggests that previous findings might have overestimated the benefits of alcohol. Notably, the protective effects of alcohol, where observed, were specific to women in these more controlled analyses, with no significant reduction in diabetes risk found in men at any level of alcohol consumption. But if we consider some of the mechanisms of alcohol on blood glucose, these protective effects start to make some sense. The hypoglycemic effects of alcohol are well known. Acute consumption of alcohol lowers blood glucose levels, but it's not entirely clear why this happens, though a few mechanisms have been proposed. One of these relates to alcohol's effect on the pancreatic microcirculation. When alcohol is consumed, pancreatic blood flow is redistributed from the exocrine portion of the pancreas to the endocrine portion, which is the area that produces insulin. This enhances insulin secretion and evokes a drop in blood glucose levels. Several listeners and members have commented that they can see a notable drop in their glucose levels on their continuous glucose monitor after consuming alcohol, which I have also repeatedly noted the same thing. This could be one reason why. Alcohol consumption might affect blood sugar control and insulin sensitivity in several ways. Firstly, alcohol is thought to potentially improve insulin sensitivity. This could be due to its anti-inflammatory effects or through influencing levels of adiponectin, a hormone produced by fat tissue. Adiponectin plays a crucial role in enhancing insulin sensitivity and reducing inflammation. While studies have consistently shown that alcohol has an anti-inflammatory effect, it does appear to increase adiponectin levels. In terms of direct impacts on glycemic control, some intervention studies support the idea that moderate alcohol consumption can decrease fasting insulin levels and improve HbA1c, which is a measure of average blood glucose levels over several months. Notably, these benefits have been observed in individuals without diabetes, and interestingly, the improvement in insulin sensitivity seems to be more pronounced in women. The overall evidence suggests that consuming about 1 to 2 drinks per day may offer the most significant protective effect against developing type 2 diabetes. This protective effect may extend to up to 4 drinks per day for both men and women. Mechanistic studies, that is, studies looking at how alcohol affects the body on a biochemical level, also support the notion that alcohol can beneficially influence blood glucose regulation. Furthermore, the data indicate that women might experience a more substantial protective effect from alcohol regarding diabetes risk compared to men. However, again, it's crucial to state that for individuals with diabetes or for those at risk, the potential benefits of consuming alcohol should not be seen as a substitute for more effective and safer measures like proper diet and exercise. These lifestyle interventions provide significant health benefits without the risk associated with alcohol consumption. Consuming alcohol for the sole purpose of improving blood glucose would be misguided. Alcohol consumption, particularly when it reaches hazardous levels, can significantly impact metabolic health, largely through its effects on visceral fat. Visceral fat is not just any fat. It's a hormonally active type of fat that wraps around your internal organs, such as the liver, pancreas, and intestines. Unlike subcutaneous fat, which is stored beneath the skin, visceral fat has unique biochemical properties and releases inflammatory cytokines. These cytokines disrupt normal organ functions and can lead to serious health issues, including cancer, cardiovascular diseases, and metabolic syndrome. One of the clear indicators of increased visceral fat is a larger waist circumference. Intriguingly, studies have shown that even for individuals whose BMI falls within the normal range, a waist circumference greater than 120 centimeters, about 47 inches, for men and 100 centimeters, which is about 39 inches for women, nearly doubles the risk of premature death. This highlights the specific danger of visceral fat independent of overall body fat. There's also good evidence that alcohol can lead to a larger waistline, especially when one engages in so-called hazardous drinking, which is defined as having 3 or 4 drinks on 4 or more occasions during the week. In a study of adults aged 59 to 83, those who reported being current hazardous drinkers had a 2.4 centimeter larger waist circumference compared to people who never reported hazardous drinking. But being a former hazardous drinker also carried a risk of a larger waist circumference. Even people who stopped their hazardous drinking before the age of 50 had nearly a 1.2 centimeter larger waist circumference, while those who stopped after the age of 50 had a 1.88 larger waist circumference. Being a hazardous drinker at every decade of life was associated with the greatest increase in waist circumference, nearly 4 centimeters larger compared to never hazardous drinkers. This is evidence that not only does heavy alcohol consumption likely lead to a larger waist circumference, but also that a longer duration of consumption carries a greater risk. Drinking into old age seems to be particularly bad for adding to your waistline, and if you are a heavy consumer of alcohol, stopping sooner rather than later is really good advice. Several Found My Fitness members also had questions about whether different types of alcohol are better or worse for health, and that seems like it could be the case for body fat levels. For example, consuming mostly beer or spirits as the main type of alcohol is actually associated with a greater visceral fat mass, while consuming red wine is associated with less visceral fat mass. The increase in visceral fat due to beer and spirit consumption seems to be mediated by dysregulated lipid metabolism and inflammation. The protective effect of red wine on visceral fat was also related to lipid metabolism as well as kidney function biomarkers. Although the findings only show an association and not a direct causation, several mechanisms can help us understand why alcohol might lead to weight gain, and specifically an increase in visceral fat. One primary reason is that alcohol is highly empty calories. This means that while alcohol provides calories, about 7 calories per gram, it lacks nutritional value. This calorie content is nearly twice as high as those of proteins or carbohydrates, both of which provide 4 calories per gram, but less than 9 calories per gram found in fats. When these excess calories from alcohol are consumed, they directly contribute to weight gain. Additionally, alcohol affects the body's metabolism in ways that promote fat accumulation. For example, alcohol consumption can reduce the rate at which your body burns fat, a process known as fat oxidation. At the same time, alcohol can increase your appetite and lead to overeating. This effect can be exacerbated if the drinking and subsequent overeating occur late at night, which is often the case. Late night eating combined with reduced fat oxidation and increased calorie intake from alcohol makes it easier for the body to store fat, especially around the midsection as visceral fat. Furthermore, while alcohol does have a slight thermogenic effect, meaning it can slightly increase energy expenditure as the body processes it, this small increase typically does not offset the high number of calories alcohol contains. Therefore, the net effect of consuming alcohol is more likely to contribute to weight gain rather than help in burning calories. Let's wrap up this section on alcohol metabolism. There's a pretty strong evidence that low to moderate alcohol consumption is related to a lower risk of diabetes, and there's even some good mechanistic evidence to indicate a blood glucose lowering effect of alcohol. The greatest protective effect of alcohol occurs at around 1 to 2 standard drinks per day. This is a dose where alcohol may have benefits related to glycemic control. But I don't think that the potential protective effect against diabetes outweighs the risk of a larger waist circumference and the adverse effects of alcohol on blood lipids that might promote an elevation in visceral fat. Furthermore, because of the risk of diseases like cancer that are associated with low and moderate alcohol intake, it certainly wouldn't make sense to start consuming low to moderate levels of alcohol for the sake of improving glycemic control or reducing your risk of diabetes, where exercise would be the best lifestyle intervention for that. The next area I want to discuss is how alcohol affects reproductive health and fertility. Specifically, I'll focus our discussion on how alcohol can impact sperm and egg quality, as well as important hormones that relate to reproductive health, such as estrogen and testosterone. This was an area where several of you had questions or concerns about how alcohol may affect reproductive organs and fertility, so hopefully I'll clear up some of that in this discussion. I think the best place to start is a brief overview of our body's hypothalamic pituitary gonadal axis, or the HPG axis, which involves a cascade of hormones that regulate reproductive function. In the first step of this cascade, our hypothalamus releases gonadotropin-releasing hormone into the system of blood vessels that connect the hypothalamus and the pituitary gland. Gonadotropin-releasing hormone then stimulates pituitary gland to release follicle-stimulating hormone and luteinizing hormone into circulation. Follicle-stimulating hormone stimulates development of egg follicles in females, and luteinizing hormone stimulates the development of sperm in males. Follicle-stimulating hormone and luteinizing hormone also stimulate the ovaries and testes to produce and release estrogen and testosterone, respectively. It's without a doubt that the HPG axis must be working properly for a healthy reproductive system. So how does alcohol affect the HPG axis? Alcohol consumption generally results in an acute increase in gonadotropin-releasing hormone, luteinizing hormone, follicle-stimulating hormone, and estrogen or estradiol, and a decrease in testosterone and progesterone. Alcohol's effect on testosterone may be dose-dependent. A low to moderate intake seems to elevate testosterone levels, and a higher intake seems to reduce testosterone levels in men. Alcohol seems to affect every step in the cascade of the HPG axis. For one, alcohol can disrupt luteinizing hormone gene expression in a way that alters its potency to stimulate the production of testosterone and estrogen. Alcohol may also affect the sensitivity of gonadotropin-releasing hormone receptors in the pituitary gland, and therefore lower luteinizing hormone production and secretion. Overall, disruptions to hormone production and secretion in the HPG axis appear to result from increased inflammation and oxidative stress resulting from the metabolism of alcohol. The effects of chronic alcohol exposure on HPG function are somewhat different to the acute effects. There is a decrease in gonadotropin-releasing hormone, luteinizing hormone, testosterone, and progesterone, and an increase in estrogen or estradiol and follicle-stimulating hormone, resulting in reproductive dysfunction disorders like irregular menstrual cycles, reduced fertility, and hypogonadism. Let's now take a look at how alcohol affects males and females separately. Alcohol consumption has been associated with several reproductive disorders in women, including irregular menstrual cycles, absence of ovulation, and increased risk of spontaneous miscarriage, and early menopause. Compared to women who don't drink alcohol, women who drink are 74% more likely to experience pain during sexual intercourse, a lack of sexual desire, and disturbances in sexual arousal or orgasm. They are also 45% more likely to experience premenstrual syndrome, also known as PMS. Heavy drinking, defined as consuming one or more standard drinks per day, further increases the risk of PMS to 79% when compared to never drinking. Alcohol consumption also reduces the ability of women to experience a pregnancy. Compared to women who never drink, light drinkers have an 11% lower chance of pregnancy, and moderate drinkers have a 23% lower chance. Light and moderate drinking were defined here as consuming less than one standard drink or more than one standard drink per day, respectively. For every one extra drink per day, the chance of experiencing a pregnancy dropped by 2%. However, some studies suggest that avoiding alcohol altogether may not be necessary to achieve a pregnancy. In one observational study of Danish women, consuming up to 14 alcoholic drinks per week did not affect fertility, which was only negatively impacted when women consumed more than 14 drinks per week. The type of alcohol consumed didn't seem to matter. Beer or wine were associated with the same odds of fertility among drinkers. There's also some evidence that consuming alcohol may reduce egg and embryo quality. In a study of 54 women taking part in a program for in vitro fertilization, there was a dose-response relationship between alcohol consumption and embryo quality. The study classified embryo quality as Class A being embryos with the highest reproductive potential, Class B being embryos with slight deviations in reproductive qualities, and Class C being embryos with considerable abnormalities. Among the women who reported consuming any alcohol, only 4% of the embryos were classified as Class A, while 87% were Class B and 9% were Class C. Among the women who didn't consume alcohol, 42% of the embryos were Class A, 39% were Class B, and 19% were Class C. In other words, consuming alcohol appears to cause some abnormalities in embryos and downgrade them from Class A to Class B. The dose of alcohol consumed also matters. In the same group of participants, only 15% of embryos were classified as Class A for women who consumed up to 25 grams of alcohol, or an equivalent of just 2 drinks per day. Class A embryos constituted just 4.5% of the embryos for women who consumed more than 2 drinks per day. However, among the women who reported only sporadic alcohol consumption, Class A embryos constituted 44% of the embryos, and for those who reported total abstinence from alcohol, Class A embryos constituted 70% of the embryos. Let's look at these results in another way. More Class B embryos came from women who consumed more than 25 grams of alcohol per day. So 72% were Class B embryos compared to those who consumed alcohol sporadically. Only 44% of those were Class B embryos. And those who abstained from alcohol, only 30% of those were Class B embryos. The conclusion here is that consuming more alcohol leads to more abnormalities in embryos and a decreased reproductive potential. Looking at embryo quality is one thing, but is there any evidence that alcohol leads to worse pregnancy outcomes among women who undergo IVF or intracytoplasmic sperm injection, another assisted reproductive technology? Overall, consuming alcohol does not appear to have a strong association with achieving a pregnancy after IVF or intracytoplasmic sperm injection. However, the dose of alcohol again seems to be important. There is a negative association between alcohol consumption and the odds of achieving a pregnancy when a woman's weekly alcohol consumption exceeds 84 grams, which is the equivalent of about 6 standard drinks. That amount would be considered moderate drinking for women. If we compare moderate drinking women to women who abstain from alcohol, the chance of achieving a pregnancy after IVF or intracytoplasmic sperm injection drops by about 7%. What's also interesting is that paternal alcohol consumption was also associated with a lower chance of their partner achieving a pregnancy when the father consumed 6 or more drinks per week. The chance of their partner achieving a live pregnancy fell by 9%. Alcohol consumption has also been associated with changes in several hormones in premenopausal women. An acute dose of alcohol equal to 0.7 grams per kilogram of body weight increases plasma estradiol levels by 55 to 66% above baseline levels, and consuming a similar dose every day in the morning and evening for 1 week elevates total testosterone levels. Daily consumption of 30 grams of alcohol also causes elevations in plasma levels of DHEAS in the follicular phase, estrone and estradiol in the periovulatory phase, and estrone, estradiol, and estriol in the luteal phase. Now let's talk about male sexual health and fertility. Light to moderate consumption of 14 or fewer drinks and even high consumption of 14 or more drinks per week is associated with a lower risk of erectile dysfunction in males. However, any alcohol consumption does appear to reduce semen quality in males. An analysis of over 40 studies involved more than 23,000 men observed that drinking alcohol reduced semen volume, reduced antioxidant enzymes present in semen, and lowered levels of testosterone, follicle-stimulating hormone, and luteinizing hormone. But drinking did not influence sperm density, motility, morphology, or DNA fragmentation. In this study, drinking 1 to 7 alcoholic drinks per week appeared to offer protection against these effects, as no significant changes were observed in semen parameters or sex hormones. However, having more than 7 drinks per week was associated with lower semen volume, testosterone, and follicle-stimulating hormone, as well as higher levels of estrogen and luteinizing hormone compared to non-drinkers. Other studies had confirmed that consuming between 4 and 7 drinks per week may improve fertility compared to drinking 1 to 3 drinks or 8 or more drinks per week. While heavy alcohol consumption of 25 to 40 or more drinks per week leads to drastic reductions in sperm count and normal-looking sperm. Despite some of this evidence I just presented, I really want to emphasize that expecting parents or couples who are hoping to become pregnant should really think about their alcohol use. There is some good evidence that drinking behavior by the mother and father before conception can really have an impact on the baby's growth and development. This even applies to the time before you know you are pregnant. I'll talk about a few impactful studies here, but note that most of these studies were conducted in rats or mice, unless I specify. In one study, consuming the equivalent of 5 standard drinks around the time of conception caused the offspring to have impaired glucose tolerance and reduced insulin sensitivity when they were 6 months old, which could translate to a higher risk of childhood type 2 diabetes and obesity if these findings extend to humans. In a similar study, exposure to binge drinking levels of alcohol before conception led to smaller offspring body weight and reduced behavioral and pubertal development, regardless of which parent was exposed to the alcohol. I want to underscore the last point about paternal alcohol consumption also having the ability to influence the health and development of the child, because normally it's only the mother whom we think about. Paternal alcohol intake has been linked to deficits in skull and facial growth and development, reduced organ growth in the heart, lungs, liver, and kidney, and impaired development in brain regions responsible for complex cognitive functions and behavior, several which are characteristic of fetal alcohol spectrum disorders. What can you do if you're an expecting parent and trying to reduce these risks? Well, researchers in this field suggest that fathers, and probably mothers too, should abstain from alcohol for at least 3 months before trying to get pregnant to make sure that any lingering effects of alcohol on sperm and egg quality and function are minimized. This is longer than the 1 month that has been previously recommended, but I think it's better to be overly cautious and safe than sorry. So fathers are just as responsible as mothers for ensuring that they are engaging in low-risk drinking habits prior to their partner getting pregnant. These emerging data are, in my opinion, so incredibly important because, as you're probably aware, labels on alcohol products typically only caution pregnant women to avoid alcohol. Now, based on good scientific evidence in animal models, these labels should probably include information on expecting mothers and fathers. The ability of a father's behavior to influence their offspring's growth is related to epigenetic changes that I'll discuss shortly, and it really emphasizes that the health of both parents is super important to ensure a healthy, happy child. Now I want to discuss how alcohol affects sex hormones in men because testosterone is often brought up as something that men are concerned about. Regarding testosterone, results from some studies in humans and in vitro studies are somewhat mixed. In general, chronic heavy alcohol consumption is associated with lower testosterone levels, while low to moderate alcohol consumption does not appear to reduce testosterone and may even increase testosterone levels somewhat. The main mechanism to explain an increase in testosterone levels with low to moderate intakes of alcohol is an increase in detoxification enzymes in the liver. Metabolizing alcohol requires the enzyme alcohol dehydrogenase and nicotinamide adenine dinucleotide, or NAD. Using up NAD increases the NADH to NAD ratio, which activates the liver enzyme 17-beta-hydroxysteroid dehydrogenase. When this happens, more of the hormone androstenedione is converted into testosterone. The main mechanisms by which heavy alcohol consumption reduces testosterone are through its effects on the HPA axis, oxidative stress, and inflammation. Here, I'll briefly focus on the HPA axis, which is the cascade involved in our body's so-called stress response. Consuming alcohol stimulates corticotropin-releasing hormone, or CRH, from the hypothalamus. CRH causes the release of adrenocorticotropic hormone, or ACTH, from the pituitary gland. And finally, ACTH stimulates cortisol release from the adrenal gland. High levels of cortisol, especially chronically high levels, blunt testosterone production and secretion from the testes. As a wrap up to this discussion on fertility, I want to discuss how alcohol can affect the health of newborns through its epigenetic effects. I already discussed some of this information when I spoke about how maternal and paternal alcohol consumption can impact fetal health, but it's important enough to underscore and expand upon. What I'm going to talk about is different from maternal alcohol consumption during pregnancy, which is highly cautioned against. There is no safe level of alcohol consumption during pregnancy or even when trying to get pregnant. Fetal alcohol spectrum disorders are entirely preventable if you avoid exposing yourself and the baby to alcohol during these crucial time points. It is well known that drugs, cigarette smoke, dietary micronutrients, and alcohol in utero can have effects on the developing embryo that might manifest during childhood and can even last until adulthood. But even before conception, when a mother's eggs are maturing, environmental and dietary exposures can still impact characteristics of eggs and the health of the child after birth. During the egg maturation phase, a process called genomic imprinting occurs and impacts literally every cell of the developing child. One study observed that mothers who consumed alcohol at any point were less likely to have children with a genomic imprint at a non-coding RNA known as NC886. Even though the consequences of this epigenetic change aren't quite apparent because of the function of NC886 aren't really known, I use this study as an example to highlight how preconception exposure of mothers, and probably fathers, to diet and lifestyle factors like alcohol consumption can potentially affect long-term health of their babies. It's never too early to start thinking about this stuff, especially if you're planning on having children. Maternal alcohol consumption can clearly have direct impacts on the developing fetus or her own eggs as they grow and mature. However, paternal alcohol consumption can also affect a child's health through epigenetic effects. For example, rodent studies have shown that offspring from alcohol-treated fathers have lower birth weights, lower individual organ weights, smaller brains, and impaired cognitive and motor abilities compared to non-alcohol-treated fathers. The sperm epigenome is very sensitive to environmental exposure, which likely explains why paternal alcohol consumption patterns can influence offspring phenotypes so strongly. Talking about all of the epigenetic modifications that have been studied is beyond the scope of this conversation, but I will note that the literature in rodents and humans indicates that DNA methylation is sensitive to paternal alcohol exposure. Alcohol also impacts chromatin, the genetic material comprising our chromosomes, and non-coding RNAs in sperm. As I mentioned earlier, it's clear that avoiding alcohol while you're trying to get pregnant, and especially during pregnancy, is the best way to increase your chance of a healthy pregnancy and a healthy child. That goes for the mother and father. There is not a lot of human research on the epigenetic changes associated with maternal and paternal alcohol consumption, or what the implication of certain epigenetic changes are. But it does seem that even pre-pregnancy alcohol consumption by the mother and father can alter long-term health of the children in utero and even into puberty. So let's quickly recap. For women, any amount of alcohol is associated with lower odds of achieving a pregnancy and lower egg quality. For men, the relationship between alcohol and erectile dysfunction or fertility is less certain. Consuming 1 to 7 drinks per week may not impact sperm quality and even seems to protect against erectile dysfunction, while higher levels reduce sperm quality. My recommendation based on the literature, if you're trying to get pregnant, lower your alcohol intake considerably, preferably stop altogether at least 3 months before really trying to get pregnant. There's no evidence that even a low consumption of alcohol will improve fertility outcomes in men or women. Next, I want to discuss a very common question from Found My Fitness members, and that is whether there are any differences in terms of health outcomes for certain types of alcohol. Compared to other types of alcohol, wine, and particularly red wine, is associated with health benefits, or at least viewed as less harmful than beer or hard spirits. At one point, this was believed to be due to the presence of resveratrol in red wine, but as I discussed earlier, there doesn't seem to be a case there because any dose of resveratrol from wine is going to be much too small to have a significant health effect. The World Alzheimer Report from 2022 concluded that when it comes to Alzheimer's disease, a protective effect may only exist for red wine consumption up to 4 glasses per day, but not other types of alcohol. They note that this may be due to red wine's flavonoid and antioxidant content, but they also caution that drinking 4 alcoholic drinks per day elevates risk factors that promote dementia, including high blood pressure and diabetes. For cardiovascular disease incidence, there tends to be a non-significantly higher risk in beer and spirit drinkers compared to wine drinkers. Furthermore, a U-shaped association between wine consumption and all-cause and cardiovascular disease mortality has been observed, where the lowest risk occurs around 20 grams of wine per day, or about 2 standard drinks. In the same study, however, non-wine alcohol intake was associated with a higher risk of all-cause mortality at any dose above 0 drinks per day, except for cardiovascular disease in females, where the lowest risk was observed around 0 to 1 drink per day. It's interesting that in the same study, wine intake was not associated with cancer mortality at any dose, but non-wine intake at any dose was associated with cancer mortality. Most of these associations remained even when accounting for the sick quitter effect, where former drinkers who developed health outcomes and health problems may contribute to a lower health status of the non-drinking group. Finally, drinking red wine has been associated with more favorable cardiometabolic health. An analysis of almost 2,000 participants from the UK Biobank study, drinking more red wine was associated with having less visceral fat, lower levels of inflammation, and higher levels of high-density lipoproteins, and even white wine was associated with a greater bone density. Drinking beer and spirits was associated with the opposite effects, elevated levels of visceral fat, dyslipidemia, and insulin resistance. Based on this literature, it would appear that red wine may be a better option for alcohol if you are going to drink. For many health outcomes, there's a lower risk associated with wine consumption compared to beer or spirits. However, you should view choosing wine over beer or spirits as a damage control option and not a way to achieve positive effects on health. This is particularly relevant for cancer, which we have discussed at length already. There is a linear and dose-response relationship between alcohol consumption and pharyngeal, laryngeal, esophageal, liver, colon, rectal, and breast cancer, all types of alcohol associated with increased risks. Even though red wine contains small amounts of polyphenols and some antioxidants, this doesn't seem to outweigh the alcohol content at all. One more side note about red wine. Have you ever wondered why you seem to get a headache after drinking even just a few glasses of wine, but not after drinking beer or other types of alcohol? Headaches are sometimes blamed on the preservatives or nitrites found in red wine. But one hypothesis proposes your red wine headache may be caused by quercetin 3-glucuronide, a derivative of the polyphenol quercetin that is also present in red wine. Quercetin 3-glucuronide inhibits the enzyme aldehyde dehydrogenase 2, which is responsible for metabolizing acetaldehyde into acetate. Inhibition of this enzyme means that we will have higher levels of acetaldehyde in the body after consuming red wine, which can lead to the appearance of headaches in some people, especially those who are susceptible to headaches. Although this hypothesis has yet to be tested in humans, it provides a plausible explanation for why red wine causes headaches in many people. The last topic that I want to discuss is exercise. Alcohol and exercise don't seem like they'd be discussed together, but many Found My Fitness members had questions about how they could enjoy alcohol while also making progress with their fitness. We will cover how exercise could be used to counter alcohol cravings, how alcohol affects exercise performance and recovery, and if exercise actually lessens the damaging effects of moderate alcohol drinking. All of you know that I am a huge fan of exercise, and there's actually some pretty interesting research on the effects of alcohol on exercise performance and recovery. Alcohol is commonly used to socialize after exercise to celebrate a big achievement like running a marathon, often along with some good food. And at this time, most people aren't thinking about optimizing their adaptations or recovery. It's just about having a good time. First, let's talk about alcohol and performance. It's obvious to me that you would not want to have even 1 or 2 drinks right before a workout. There are 0 aspects of alcohol that would help improve endurance, strength, or speed. From the evidence that is available on this topic, it seems that alcohol acutely reduces endurance performance, but may not have major impact on strength, even at high doses. What seems to be more relevant is how alcohol impacts recovery from exercise and adaptations to training. Again, there's not a ton of evidence here, but there is some. So in order to recover properly from exercise and get the most out of training, hydration, refueling, accelerating muscle tissue damage are really important. Consuming alcohol after exercise appears to have a negative effect on hydration status, but only at a dose of nearly 1 gram per kilogram of body weight, which would be around 5 or more standard drinks for most people. At a dose less than 0.5 grams of alcohol per kilogram of body weight, alcohol may not impair rehydration. Whether you should be concerned about alcohol's effect on hydration after exercise probably depends on how soon you'll be engaging in exercise again. It may not be that consequential. Alcohol also doesn't appear to impair the ability to restore muscle glycogen after exercise, as long as it's consumed with a post-exercise meal that contains carbohydrates. Of course, if an alcoholic drink or two displaces some food you might be eating, then this might compromise muscle glycogen replenishment. Alcohol may also be detrimental for recovery from injury. For one, alcohol impacts our immune system in a way that suppresses some pro-inflammatory cytokines such as TNF-alpha and IL-1 beta and IL-6 and increases levels of some anti-inflammatory cytokines. This might seem like a good thing, but when we're dealing with an acute injury, we actually want an inflammatory response at the site of injury to initiate the healing process. There is also some research, though very limited, that suggests alcohol may have effects on skeletal muscle blood flow and anabolic hormones like testosterone that are crucial to the healing process. When consumed after a session of exercise, alcohol blunts muscle protein synthesis for as much as 24 hours after. Type 2 muscle fibers, the so-called fast twitch fibers, seem to be more susceptible to the effects of alcohol, at least when looking at studies in rats and when using an extremely heavy dose of alcohol. And lastly, consuming alcohol after exercise has been shown to worsen the declines in muscle performance after muscle-damaging exercise, meaning that greater muscle damage may have been introduced or induced, or that recovery ability is impaired. Several of these studies have used a very high dose of alcohol that really isn't practical for any person to consume in a safe single setting, so I do think that is worth noting. In addition to negatively affecting recovery, this also means that alcohol consumption could blunt your gains. A study involving physically active males demonstrated that consuming 12 standard drinks after resistance and aerobic training, despite also ingesting 25 grams of whey protein, reduced muscle protein synthesis by 24%. This reduction was even greater at 37% when alcohol was consumed without additional protein. This shows that alcohol, even when paired with optimal amounts of protein, can blunt the anabolic response, crucial for muscle repair and growth. Essentially, alcohol can counteract the benefits of your workout efforts by impairing the body's ability to repair and build muscle tissue. Now, this study was a bit extreme because most people are not going to consume 12 standard alcoholic beverages. However, it is still likely that even small amounts of alcohol can potentially influence recovery processes and protein synthesis, but the extent and significance of these effects would be considerably less than with high levels of alcohol intake. But even a 5 to 10% reduction in protein synthesis after exercise isn't ideal for someone looking to optimize their training response. Higher doses of alcohol after exercise can hinder recovery by promoting a catabolic state, which is not conducive to muscle growth and repair. Moderate alcohol consumption, something equivalent to about 3.5 drinks, raises cortisol levels, a stress hormone that breaks down muscle, but it doesn't significantly alter testosterone. Moreover, alcohol consumption disrupts the activation of mTOR, a key protein in the pathway that stimulates muscle protein synthesis. When the alcohol dose is high, like 7.5 standard drinks for a 70 kilogram male, then it does decrease testosterone production, which is particularly important for males. I've mainly been talking about the acute effects of alcohol, but chronic heavy alcohol consumption is associated with a range of muscle abnormalities, including inflammation, mitochondrial dysfunction, oxidative stress, reduced muscle mass, enhanced protein degradation, and increased autophagy. However, this may only apply to adults who are heavy chronic drinkers. Overall, it seems that you can still consume light alcohol and reap the benefits of exercise, but it is clear that drinking alcohol will probably reduce exercise recovery and adaptation somewhat when compared to the same exercise regimen without alcohol. There's one more study I want to talk about that looked at the longer-term effects of consuming a moderate dose of alcohol on the improvements in VO2 max after high-intensity interval training, or HIIT. This was known as the BEER-HIIT study. For 10 weeks, all of the participants performed high-intensity interval training twice per week. Some of the participants consumed beer, some consumed sparkling water with vodka, and some consumed water or non-alcoholic beer. Men in the alcohol group consumed 1 standard drink with lunch and dinner on Monday through Friday, and the women consumed 1 standard drink at dinner. All of the groups increased their VO2 max at the end of the study, and there were no differences between the groups, indicating that low to moderate alcohol consumption may not get in the way of the cardiorespiratory fitness improvements during high-intensity interval training. A final point I'd like to discuss along the lines of exercise and alcohol is the potential of exercise to treat alcohol use disorder and perhaps reverse some of the damage to the brain caused by long-term alcohol use. We've already discussed some of the damaging effects of chronic heavy alcohol use on the brain. They're not good. If you're a regular listener of my podcast, then you'll be aware of the incredible benefits of exercise on brain health and cognitive function. In fact, many of the ways that exercise benefits the brain are the same pathways by which alcohol damages it. But unfortunately, there hasn't been much research into the interaction between alcohol and exercise. But I do want to bring up a study from 2013 that provided some evidence that regular exercise may protect the brain from some damage related to heavy alcohol consumption. In a group of 60 adults, heavy alcohol consumption was associated with less white matter integrity in 2 specific brain regions. However, in the participants who reported the average or above average levels of exercise, alcohol consumption was not related to less white matter integrity. There was one other interesting finding that deserves some attention. In the participants who didn't exercise regularly, there was a strong positive association between alcohol consumption and a loss of control over drinking. And this relationship was not as strong for the participants who engaged in exercise regularly. This would suggest that exercise seems to play an important role in modulating alcohol intake or cravings of alcohol, which is actually well supported based on some literature as a reason for exercise being incorporated into alcohol treatment programs for over 40 years. Similar to alcohol, exercise activates brain reward circuitry and may reduce cravings for alcohol. Meta-analyses show that exercise interventions reduce drinking volume among people with alcohol use disorders and even improve their VO2 max. There are many proposed mechanisms as to why exercise might reduce drinking behaviors. Some of these are psychological and include enhancing self-efficacy, reducing stress, promoting social interaction, improving mood, and mitigating symptoms of comorbid depression and anxiety, which are common among adults with alcohol use disorder. Regarding physiological mechanisms, exercise triggers the release of beta endorphins and modulates the endorphin opioid system, both of which are involved in pain pathways and reward processing. It seems that high levels of beta endorphins released during exercise can substitute for alcohol consumption and reduce one's desire to drink. There's also dopamine, which is increased during acute exercise and sustained during chronic exercise training. The rewarding effects of alcohol consumption are associated with the dopamine pathway, and therefore exercise might be one way to reduce the susceptibility to alcohol use. There's one final and super interesting pathway that I want to discuss related to exercise and alcohol, and it's a pathway that involves the exercise hormone or exerkine called fibroblast growth factor 21 or FGF21. During exercise, FGF21 is released by our liver and muscles, and it can cross the blood-brain barrier and bind to receptors in the hypothalamus. It plays a role in many of the beneficial responses to exercise, like improved glucose uptake, insulin sensitivity, lower blood cholesterol levels, and reductions in body weight. FGF21 also alters dopamine signaling. While exercising increases FGF21, one of the most potent triggers for FGF21 release is alcohol intoxication. FGF21 actually acts as a negative feedback mechanism to decrease subsequent alcohol intake through a liver-brain signaling axis. Even more fascinating, in my opinion, is the fact that FGF21 also protects against alcohol intoxication. If we could find a way to translate the potent anti-alcohol effects of FGF21 to humans, this could have, in my opinion, some major implications. There is some evidence that FGF21 may have a therapeutic potential for alcohol use disorders. Studies in humans have found that single nucleotide polymorphisms in genes involved in FGF21 signaling lead to greater alcohol consumption. In animals, FGF21 tells the brain whether to drink more alcohol. Mice who can't release FGF21 drink more alcohol, and increasing FGF21 decreases alcohol consumption even when given as a drug. When an analog of FGF21 was administered to mice and monkeys who were addicted to alcohol, their alcohol consumption decreased by 50%. Increasing FGF21 levels thus appears to be a strategy to decrease the preference for alcohol across species. How does this relate to exercise? Well, exercise is one of the most potent ways to naturally increase FGF21 because it's an exerkine released during physical activity. Endurance exercise, specifically cycling at 70% of VO2 max, increased FGF21 levels by almost fourfold over baseline levels 1 hour after exercise. FGF21 levels don't increase after resistance training, however. Endurance exercise is better for increasing FGF21 levels because it results in a higher metabolic demand compared to resistance training. This leads me to believe that high-intensity interval training, or HIIT, may also offer an especially potent benefit for alcohol use disorder due to its benefits on FGF21, but also because of the well-known effects of vigorous exercise on brain-derived neurotrophic factor, or BDNF, which you have all heard me talk about in several previous podcast episodes. BDNF is thought to be one of the main transducers of the antidepressant effects of exercise and could likely complement the effects of FGF21 and other exercise-induced hormones and neurotransmitters to influence alcohol consumption. But until this has all been studied in randomized controlled trials, I can't make any strong conclusions. Let's summarize the influences of alcohol on exercise and exercise on alcohol consumption. Alcohol at a dose of 1 gram per kilogram of body weight impairs exercise recovery. Because this would equate to 5 or more drinks in one sitting for most people, you may not need to be concerned if you're just having 1 or 2 drinks after exercise. But I would certainly avoid high volume alcohol consumption after exercise. But of course, really at any time, if your goal is to optimize recovery and adaptations to exercise. If you are going to consume alcohol after exercise, make sure you are consuming adequate protein, at least 25 to 30 grams, and carbohydrates along with it. Replacing food calories with alcohol is the worst thing to do if optimal recovery is your goal, because remember, alcohol is empty calories. It seems advisable, based on my view of the literature, to abstain from alcohol while you are trying to heal from an injury related to exercise, as there are certainly no benefits to consuming it at this time, just like you wouldn't want to drink when you're trying to recover from an illness or infection. There is also some compelling mechanistic evidence that exercise may affect the brain in such a way that it reduces cravings for alcohol and leads to less alcohol consumption. Exercise has been used in treatments for alcohol use disorder for almost half a century and seems, based on some studies in humans, to be effective for reducing alcohol consumption among heavy drinkers. In many ways, engaging in exercise activates the same reward pathways that alcohol does. Finally, engaging in regular exercise may offer some protection against some of the negative effects of chronic alcohol use on the brain. But this is not to say that you should use exercise as an excuse to consume more alcohol. Okay, friends, we have covered a lot of information, and I want to end this episode with a section I think you've all been waiting for, and that is some practical advice and tactics for damage control. I'm including this discussion because, if we're being realistic, there are people who enjoy consuming alcohol on occasion, and I'm not going to tell you whether you should or shouldn't drink. Alcohol is a part of many social occasions, and knowing that people will consume alcohol from time to time, it makes sense to think about the lowest risk ways to have alcohol and strategies to reduce some of the adverse effects of consuming it. We just talked about exercise being one potential way. Many of these we've already discussed throughout this podcast, so I'll summarize those now, and I'll introduce a few of the key quote-unquote damage control strategies that I think are going to be the most impactful. First, I think an important note, it's abundantly clear that the number of alcoholic drinks per week that will be associated with optimal health is 0. I know that throughout this episode, I've cited studies showing that low and even moderate levels of alcohol consumption are associated with lower risk of certain diseases, but none of this evidence suggests that someone who doesn't consume alcohol should start to consume alcohol to obtain that health benefit. Rather, they suggest that if your currently drinking habits reflect low to moderate alcohol consumption, you may be within a safe range. And if you're consuming more than this amount, reducing your intake should provide a health benefit. But of course, your baseline health status and predisposition to diseases like cancer should play a role in your decision to drink or not. So, if you are going to drink, what is the safest level of alcohol consumption? From a disease reduction standpoint, the literature suggests 1 to 2 drinks per week. This recommendation is largely driven by the evidence on cancer, which has a very low risk threshold for drinking. Even though 1 to 2 drinks per day seems to lower the risk for cardiovascular diseases and diabetes, this amount seems to elevate the risk of dementia and cancer and reduce life expectancy. And I don't think that the cardioprotective or glucose-lowering effects of alcohol outweigh the greater risk for cancer or cognitive decline. Also, it's clear that you should avoid consuming 4 to 5 drinks on any single occasion or binge drinking, because binge drinking is associated with adverse health effects even when your weekly alcohol consumption falls within the low risk or even cardioprotective range. There is admittedly a very poor quality literature about things that may or may not mitigate these adverse effects of alcohol. Regarding sleep, the dose and timing are probably the 2 most important factors. If you have your last drink 4 hours or more before going to sleep, this seems to drastically reduce the impact on sleep quality and sleep architecture. Consuming a meal before having any alcoholic drinks at night, and even adding some fruit to this meal and ensuring that you're staying hydrated with electrolytes and water, may also minimize alcohol's effects on sleep. But there really isn't much evidence to support this, just anecdotes. Lastly, because magnesium glycinate has been suggested to help with sleep in general, I think that taking this before sleep on a night when you've been drinking may be worth trying, especially because, as we've discussed, alcohol increases magnesium excretion. These same tactics for sleep also apply for reducing the severity of hangovers. Eating a heavy meal, supplementing with electrolytes, and hydrating only seem to help mildly with hangover symptoms. While speculative, supplementing with N-acetylcysteine and liposomal glutathione, both of which are intended to increase glutathione levels in the body and brain, may reduce some of alcohol's damaging effects and aid in detoxification processes in the liver. Because sulforaphane has also been shown to increase glutathione plasma levels and brain levels in humans, this represents another supplement option that could reduce alcohol's negative effects. A low-cost and risk-free strategy would be to supplement with a micronutrient-rich multivitamin to replenish your body's micronutrient stores, which may become depleted after a day or night of consuming alcohol. Remember that some vitamins like vitamin B3 and zinc actually are crucial for helping convert alcohol into less harmful metabolites before they leave the body. In this case, you should also ensure that your micronutrient levels are adequate in general in order to make sure your body has the enzymatic machinery necessary to metabolize alcohol. But of course, micronutrients are important even if you don't consume alcohol. Lastly, I would advise against taking NSAIDs like ibuprofen or acetaminophen to reduce hangover symptoms, and you should especially avoid taking them with alcohol, as they could slow down alcohol metabolism or increase the liver toxicity of alcohol. The same goes with mixing melatonin with alcohol in an attempt to sleep better. This will lead to increased drowsiness and may not be safe. Briefly, let's recap the list of supplements that may work for mitigating some of the adverse effects of alcohol. Remember that most of these things on this list are speculative. Liposomal glutathione, N-acetylcysteine, and sulforaphane to increase glutathione levels and help with liver detoxification processes. Zinc, magnesium, and B vitamins to aid in the metabolism of alcohol. Electrolytes, sodium, magnesium, potassium, because alcohol may increase the loss of them in urine. How to track, assess the effects of alcohol on health. One of the biggest issues surrounding low and moderate alcohol consumption is that for some people, the effects on health aren't readily apparent. It's really hard to assess whether drinking 1 to a few drinks per week is affecting your overall chronic disease risk. But nearly everyone these days owns some sort of wearable fitness and sleep tracking device. If this is true for you, then you have a very valuable tool literally at your fingertips to measure the effects of alcohol on your sleep. Although this data may not be as useful as laboratory biomarkers, I think that it could still be useful in helping you make decisions about alcohol consumption. Take a look at your sleep metrics, your resting heart rate after a regular night and a night of drinking, and you may realize something very interesting. Lastly, I think that overall, the number one thing that you can do if you want to consume alcohol occasionally without experiencing an increase in your risk for disease is to live an overall physically active lifestyle. In fact, engaging in regular exercise lessens the all-cause mortality risk associated with drinking and almost completely nullifies the association between cancer mortality and drinking. I am not saying that you can justify an extra drink or two because you worked out, but I am saying that you can probably worry a bit less about 1 or 2 social drinking occasions each week if you regularly exercise. That brings us to the end of this episode. I sincerely hope you enjoyed and at least learned a few new things about alcohol and took away some actionable advice that you can use in your everyday life. When it comes down to it, we're all adults who can make decisions for ourselves. If you struggle with substance use or have a family history of substance abuse disorders, then maybe completely avoiding alcohol is the best decision for you. But if you are someone who enjoys an occasional drink, I think that all of the evidence discussed today suggests that you can make it a part of an otherwise healthy lifestyle if you engage in low-risk drinking behaviors, you exercise routinely, and you might use some of the other tools I've discussed at length. Thank you so much for your curiosity and commitment to understanding how alcohol affects your health. I hope you enjoyed this podcast and learned as much as I did.